All right. So good evening, everyone, and thank you for joining again. Thank you for coming back. You came back because I suspect that you loved it the first time. The second time, which was yesterday, you equally love it. And here you are today again. Thank you for showing up. Like I said, I can't imagine being here on my own. I can't be training myself. It's weird. If you didn't show up, it wouldn't be fun. It's fun because you came back, and thank you for this. I hope I've been able to impact some knowledge, maybe transfer some across in the last 2 days, and today being the grand finale. I'm going to be doing the same as well, and I'm trusting that that this is going to be what the while for you. Just as I said yesterday, that we will go over 2 hours today because we have a lot to cover. Training is fun when you spend. I'm not saying we should waste time, but when you give it your all, and that's what we do. That's what I do, and that's what most of my trainer does as well. We give it our all. We don't come here to read slides to you. We ensure that we impact the knowledge. It might be hard, for someone that haven't done this before, but trust me, if you compare what we're showing you here, and maybe some of the trainings that you've been before, you can attest that it is different. It is different because we're not just reading a slide to you. We are practitioners, and by God's grace, we also know how to communicate this information and impact it onto yourself. So thank you. All right. So today we would go shortly. Let me just take you back as usual. So this is where we stopped yesterday. Was the emphasis when I was going to stop yesterday was pretty much around security testing, why that is very, very important. But if I take you back a little, we talked about the pipelines, different pipelines. If you remember this particular one, pipelines and workflow, and if you notice there, underneath here is saying continuous monitoring. Okay, this is what you do. You monitor the whole activity from the development to the build to the test, and up until the time that you take the code and deploy it in the prod environment. Okay, so we talked about that yesterday, and we move on to talk about different pipelines. We said there's one called the container pipeline, and we said we also have the traditional pipeline. I think yesterday there was my emphasis was whatever pipeline it is, you can always customize it you can take the traditional pipeline and customize it to what you do in your own organization. All right, you can adapt it. You can take the traditional one and adapt it to how you deploy your code, or how you write, or how you develop application in your organization. But whatever customization that you do to it, it would always follow the principles, all right, of secure software development lifecycle. All right, it would always follow that principle. All right. So, but if you look at this pipelines, the traditional one that I showed you, you can see that testing actually began here. All right. So you would have developed, you would have built, and you're doing your testing at the third stage. All right, before you release and deploy your code. All right. But if you look at it carefully, if this is just going to be all about security, wouldn't you agree with me that it will be too late, for you to start to test at this stage? All right, it will be too late. You have developed, you have built, then you're doing your testing at this stage. It's a little bit too late, to start to do it, here. All right, if I take you back to the container one as well, you can see that testing starts a little bit early. All right, but up here you can see source code build and also management as well. All right, But don't forget that what we're talking about is all about, security testing. We're not really concerned about, the functional testing, because I'm training you to become a vulnerability management specialist, someone that actually tests the security of application or any other or infrastructure. All right. So here comes what I wanted to show you. So looking at the traditional continuous integration and continuous delivery, all right, pipeline that I showed you earlier on, testing is typically the fourth or the third step, across, all right, that, maybe 4 stages or that life cycle that we saw earlier on. However, there is this concept that is called shift left testing integrate. So what you can see here is called shift left, all right? So it kind of explains itself, all right? You see this logo here. So this is a company, they're into, they develop vulnerability testing solution. As a matter of fact, if you sign up for our training, we use this product, all right, for all of the testing that we do. And, if you decide to sign up, and you're doing the practical, you'll be doing the practical with this particular, piece of, solution. All right. So this framework that you see here, it was from this organization. All right. But if you look at, the middle, you can see here, backlog, code and commit, build and test, deploy, and monitor. All right. So you can liken this one, what's going on, this direction flow here. You could liken it to a pipeline. All right. So that's why I said your pipeline, each of those stages are customizable. All right. As long as it follows the principles of secure software development lifecycle. All right. You can customize it. You don't have to do it the way every other person is doing it. But as long as you do not violate, the principles, of SDLC. All right. So because what you see here, what I showed you earlier on is slightly different from, how this company, represented here. But the end goal is always the same thing. Okay. So with this framework, so that this thing does not confuse you, so that's why I'm emphasizing it, that you can adapt it, to your own organization. All right. But if you now look, for the traditional one that I showed you, the emphasis was, testing start pretty much late in that entire workflow. All right. So what this framework is now suggesting is shift security to the left. All right. Take it to the left. Start security from the beginning. So, we know that development is going to the right. Okay. So maybe I should take you back a little bit to show you what I'm talking about. Let's go to this one. All right, you see, development is going in that direction. All right, it's going to the right. But what, that test methodology is saying is shift security to the left. Let security start from the beginning. Why development is going that way? But let security also now start from the beginning. All right, so while you're developing, while you're building, security should start from there. Security should not be left too late. All right. So here is in the start stage. Now, as a matter of fact, if you look at some other pipelines, you might have even more than 4 stages here. All right. But shift to the left. So what that simply means is, in the development stage, the moment that, an idea, all right, to develop a piece of application is conceived at the initial stage, you should also start to think about, the security implication, all right, whilst you're gathering requirement. Is anybody a PM here or a business analyst? Anybody a business analyst here? Anybody? Someone say my audio is low. Is that correct? Alex, is my audio low? Okay. Yeah, my audio is not low. I think it's your computer. Maybe you have to check it. Okay. All right. So the reason why I asked is if anybody's the business analyst here, So business analysts, they do well, especially when they're in the projects. One of the major tasks, all right, that they perform is they gather requirement, okay? They do requirement gathering, all right? So what we're saying here is, if you imagine that you want to develop a piece of application, whether, let's say an application to trace and track, or track and trace, this COVID application. Let's say that's what you have been employed. So someone is developing that application, but you've been employed as a BA. All right. So that application will track, you and whether you had COVID and all of that. But what we're essentially saying here is, whilst requirement to develop that application, around what that application we do in terms of the functionality, all right, at the early stage, when that idea was conceived, security, requirements should also, be gathered as well. And whilst you're testing that application at the early stage, testing should also commence for security at the early stage. That's what this picture is all about. All right. Shift to the left. Don't leave it till too late. Start to test, as early as possible, in the workflow. All right. I hope that helps. So let us look at what is shift to left testing. So shift to left testing integrates software testing practice, including security, as early as possible in the software development lifecycle. All right, that's just what it's all about. All right, this means that development and operation team, are enabled through process and tooling to share in the responsibility of delivering secured, high-quality software. All right, but you see, why I keep saying that, why I mentioned, what a business analyst will do is, you see, you cannot test a piece of product. I'm talking about security testing now, just on nothing, or you know what I mean. You must have gathered some set of requirement upon which you would test the product on. All right. So whilst the software is being built, security is built into it. All right. And those requirements that has become a function in that application is also tested along as well. All right. So shift left testing and shift left to help organization release software more often by releasing common bugs and security issue bottleneck. Okay, so I think this is just pretty straightforward, what I'm talking about here, and I'm sure that you get the concept. All right. So now that we've talked about all of those nice things about the pipelines, what it means, the stages in a typical pipeline, the difference between container pipeline and traditional pipeline, and we've seen why it is important for us to carry out security testing. So what is a software vulnerability? Why do we even carry out this security testing in the first place? All right, so these are a few description or definition of what software vulnerability is about. Number one, when we say software has vulnerability, it could mean that there is a bug in the code, or there is a flaw in the software design that could be exploited to cause a damage to that software. All right. We all know what bugs are. All right. Some of us, you might have maybe knowledge of design as well. All right. So if this design of the software is fundamentally wrong, all right, that could be a potential, security. It could lead to a potential security hole in that application. All right. And that exploitation might come, or might occur as a result of authenticated and also unauthenticated attack. All right. It could also be as a result of misconfiguration, through which an attacker can directly gain unauthorized and privileged access, to the system and also to the network. All right. So when we say, there is a vulnerability, that vulnerability could be in the application. There could also be vulnerability in the network or in the system as a whole. All right. It could also mean a gap in the security procedure or weakness in internal controls that can be exploited and that could result into security breach. All right. So this is, how you would define, software vulnerability. Don't forget, if there is a bug in the software, all right, the reason why, most of you know, if you get, a patch update request, for your phone, for example, what the vendor is trying to do at that particular time is maybe they have come to identify a bug, and what the patch would do, all right, is to make sure that the bug is removed, or the hole, security hole in the piece of software, is covered up or removed as a result of the patching that you would apply. You would agree with me that, not quite often. All right. If you're using an Apple phone or iPhone, there's always this, software upgrade, or the, upgrade of the application. You would get a notification from Apple, and it will say at a particular time, this software will be upgraded. The upgrade of the software, or when patches are released, sometimes they may not necessarily mean. So the upgrade of software may not necessarily mean that they are trying to fix, or correct a bug in the software. It might just be that, maybe they have a kind of enhanced feature, all right, that they wanted to introduce, maybe to your, to your assets. So they would ask you to click at a particular time. It would upgrade your phone. I mean, it would upgrade, the current software or application that you have into a newer version. But when there is a bug, they also release specific patch, to fix that problem as well. We're still going to come to, patching, all right? And also misconfiguration as well, all right? So don't forget that, developers are human beings, all right? They're not robots, okay? So they can make mistake in the course of writing or developing their codes, all right? And hence, it's important that, you start to test as early as possible, all right, in the development process, so that you can identify that misconfiguration and you can, work with the development team, to fix it, okay? So security vulnerability testing in software development lifecycle, all right? So we have two types of testing that are done, all right? We have what we call static application security testing. And I want you to note this, it's very, very important. Then we also have what we call the dynamic application security testing, all right? So vulnerability testing can take various forms, all right? And I've just mentioned them to you now, all right? You can take the first one, which is the stats, and we can also take the DAS as well, all right? But both of them, they are different, all right? So the stats, which is a white box method of testing, it examines the code, all right, to find software flaws and weakness, such as SQL injection, buffer overflow, cross-site scripting, and other listed in the OWASP top 10. All right, if you're not familiar with OWASP top 10, Alex, do me a favor. The link to OWASP top 10, please, can you take it and whack it into, into our chat box? All right. So if you look at the description of this particular, testing testing approach, or form of testing, which is the static application security testing. If you look at it very well, in the description, you would agree with me that this actually happens early in the software development. If you look at it, so it said that it examined the code. So if you go back, if you have a mental picture of the, the CI/CD, the pipeline, all right, coding usually happens early in the workflow. So what that simply means is whatever testing that you are doing, all right, remember we said that we should start to test early, going by the concept of the shift left, all right? So whatever testing that you're doing, all right, is going to take this particular form, which is the static application security testing, because there you are examining the code, all right? Before we, before technology, kind of, where we are at the moment, before now, developers alongside with the security team, when they are testing a code, they manually review codes, all right, where you look at each line of the code and you do a manual review. You would agree with me that that is not practically, well, you could, some people still do it and, still do it, but it's not practical, because if you have hundreds and thousands of lines of code, you probably will just have a problem with your eyes. If you have to look at everything, you would have a tired eye, you'll be tired mentally, and, you'll not just be reviewing anything. So hence, technology is getting better. So that product that I showed you earlier on, which is the SYNK, which is Snook, is one product that we use as well. And we use it, to carry out our static application security testing, all right, to review our code. We use that product. So this type of testing happens early enough in the software development. Then we now have the second one. Apologies for the typo there, 1-1. It's supposed to be 1-2. We have the second one, which is called, the dynamic application security testing. So this one is a black box testing method that examines an application as it's running, to find vulnerability that an attacker could exploit. All right. So I've taught you the black, the white and the black yesterday. So I'm not going to be, going over that again, because we've already talked about it anyway. All right. So this one, the dynamic one, happens pretty much later, because if you look at that, the description, they said he would examine an application. So the application is no longer a code. All right. So the code has been compiled, to become an application. So it's something that is running. All right. It is running. It is no longer, a code that you want to review. It has become an application because the code has now been compiled. All right. So this one happens later. All right. In the testing, as opposed to the first one. So this one, this is what you do later. This one, the static one, is what you do first. All right. And because it is black box, all right, you could liken this type of testing to penetration test. Remember from what I taught you yesterday, you could liken this one to penetration testing, while the first one could just be standard vulnerability, assessment or vulnerability scanning. All right, I hope this is making sense. I'm just trying to make sure that I take you back a little bit, to what I've taught you yesterday and bring you now forward into what I'm teaching you today. All right. So let's look at both of them. All right. The static application security testing and the dynamic one. Let's compare them. All right. I'm not going to waste a lot of time here. So one is white box. The other one is black. All right. The tester have access to the underlying framework, the design and the implementation. The application is tested from inside out. This type of testing represents the developer's approach. The other one is the tester has no knowledge of the technology or the framework, that the application is built on. The application is tested from outside. All right. You remember, all of those, penetration testing that I shared with you yesterday. So I believe you still remember. This type of testing represents the hacker's approach. All right. So this is what, ethical hacking will do. All right. So another one is required source code. The other one required a running application. All right. So it is, the product has already been developed. Yeah, that's what that is all about. It requires a running application. It has become, the code has become a product. All right. The source code now is still a source code. All right. You remember I gave you an example, modern software development, that you can have 3 developers, even up to 10 developers working on a product per time. And each of them would have, different, functions, that they've given for them, they've, asked them to do, that they will now compile all of that, even before they compile it. So it means that if developer A is an Indian, and you have developer B in China, you have developer D in Nigeria, and you have another developer, C, in Ghana. All right, before they compile their code, whatever they're working on, you can individually, all right, test them, each of those code for security. And when you do that, you're actually doing, which you're doing the static application security, testing. You're testing the source code. The other one, you're testing the application. All right. Finds vulnerability early in the software development. Finds vulnerability towards the end of the software development. All right. Remember, so if I take you back here, please, I will move quite quickly now. If I take you back here, I just want to remind you of something. Aha. So look at here. Testing is done. But when your testing is done, then you release, all right? You release this, it goes into the production environment. So every time you see a piece of web application that you consume, all right, that you can type www.smartlearninguk.com. Smartlearninguk.com is in the production environment. This particular website is being hosted, in an environment. But before it gets into that environment, before we totally release it into that environment, there is another set of tests that would be done. All right. So this is a product that is going. Some of you must have heard when we say a product goes live. So before the product goes live, somebody have to test it. All right. So what we're essentially saying there, before that product goes live, all right, we do dynamic. All right. That's what it says. Towards the end of the software development life cycle, vulnerabilities can be discovered after development life cycle is complete. All right, so you've done the product, you've already completed, but you now want to release it into your production environment. You do the final check, that is DAS. Then the check that you also do as well, the continuous test, black box text that you carry out, after that you have released it into the wild. That is also dynamic application security testing as well. This other one is less expensive to fix, more expensive to fix. It's no brainer. All right. When you're in a development stage, and you're still building it, you can fix all the problems fixable. All right. But the moment the code becomes a product, it becomes an application, you've coupled it together. All right. You would agree with me that it's more expensive. So it is sensible for you. So a lot of questions they would ask you. So in an interview, they could say, oh, so why do you think we should be testing early? All right. That's the answer. You're testing early so that you can reduce the cost. All right. Of rework. All right, they call it rework. So you can imagine you build a product. You've built a car. All right, car is a product, because if you go to Jaguar, Land Rover, or you go anywhere and say build me, you have a specification, and you say build me a car, they will build the car and they will hand over an end product to you. But listen, if you now find out that your product does not meet specification, all right, that you want a cream car, you want a cream leather, a cream leather seat, and they give you a black leather seat, the cost of taking that leather, out, the cream leather, the cost of taking the black leather seat out to replace it with cream leather, trust me, it would even be much more expensive, to build another car from you, to build another car for you, from start up, from ground up. All right. So it is more expensive, to want to fix, a problem, for a product that's already been, designed and completed. Can discover runtime and environmental issue. Absolutely. All right. And this one says, can discover runtime and environmental issue. Absolutely. All right. Let me explain what this is to you. You can build a perfect code. All right. Perfect. You can go and test your code. It's all working. All right. You have built to specification, and you can ensure you can tick all the boxes in terms of all the requirement. All right. But you see, it is different because now it's a code. You haven't actually run it. You don't know the behavior. You don't know how it will behave. All right. When it goes live, you don't know how it will behave when you take that code and when the code becomes an application and that application actually sits in an environment. It is totally different. All right. It's totally different. So that's why it says here, cannot discover the runtime. Runtime is different. You see, I was telling you about where you have 10 developers working together. By the time they couple all of their codes together and they run it, you might throw a different error. You might experience something different entirely. All right. And it might just be a different security issues entirely. All right. So that's why stats is limited. This type of testing, you cannot discover runtime, or environmental issues. All right. So then lastly we have typically support all kinds of software. Yeah, typically can only scan app like web application and also web services as well. Let's move on. So, So it's important for you to know that both static application security testing and their close cousins like the dynamic application security testing, they both help to find security flaws hidden inside a code, often before they get to production environment. So depending on the platform, our static application security testing and dynamic application security testing tools, can look at either the code, the source code, or code that has already been compiled. Some tools even operate automatically while a developer is working. Absolutely. All right. So the two that I mentioned to you earlier on, there are a few of them, all right, which you can see here. While the developer is developing the code, they've already been set, hence you have the pipeline that I discussed with you. They've been set, to be able to, identify errors or bug in the code, and kind of while the developer is developing, be able to, make sure that they let the developer know and the developer can make, changes while, development is going on. All right. So like I said, why the start and the DAS 2 are similar. They tend to look at different aspects of the developing code, all right, for vulnerability. The start tools are mostly designed to analyze source code. I've already told you about that. That is uncompiled. They do a good job of detecting well-known vulnerabilities. So likes of SQL injection, weak cryptography, buffer overflow. They would static application security testing would detect all of that, all right, easily, all right. But what dynamic would detect is kind of slightly different, all right. So if you look at the top 10 OWASP, I don't know if Alex has helped us, to put it on our platform. If you haven't done so, if you haven't put the link there, please, can you do? All right. So they look at different things per time. So for example, if you look at so the DAS 2 would text a complete application from outside, like a user, what a user would do, look at all the exposed HTTP. It will look at all the HTML interface, what a user would typically do, all right, because, sorry, wow. So what a user would typically do, all the functions that a user will perform when they're actually consuming the app. That's exactly, the kind of experience you would have, when you are testing with, the dynamic application security testing tool. So these are just examples of them that you have. Like I said, the fourth one under the start, we use this one, all right, to do our security testing. They are all good in their own right, but this is the one that we use in our environment. We might try this one out. I've been discussing with Alex, to see what this can, the check marks is also very, very good too. It comes highly recommended. And also when you look at most of the job that is, that is being advertised, if it's not this one, that one is also widely used as well. But let's see, if we can try another one out on our environment this year. But at the moment, we're using the Snow. All right. Then you have the dynamic one. Yeah, we have the Kinetics vulnerability scanner. We have Rapid7 inside AppSec and AppSpider. We have the NetSparker. Quite a number of them. We have Qualys. Qualys, you can also use it, to test your vulnerability as well. Quite a number of them. We have BobSuit. BobSuit, you can use it to intercept traffic. All right. That's again, if you wanted to check all of user behavior, BobSuit could also be another very, very good tool. All right. So what does this mean for you? In the real training, we would actually be testing our application out using some of these toolings. So again, if you want to get a whole lot of hands-on experience in the real training, then sign up for our January 17th cybersecurity training that is coming, so that you'll get the practical and what we've been teaching you all along. You'll be able to put it into practical. All right, or into practice rather, not practical. So everything that I have been teaching you all along, all right? Since 2 days ago that we've been, talking about. This is the third day. Another word, a much more bigger word, if that's the word, to capture everything I've been talking to you about is security assurance, all right? So vulnerability management, vulnerability scanning, vulnerability assessment, penetration testing, risk assessment, ethical hacking, security scanning, security audit, postal assessment, and all of that, they fall under one single word, all right? Security assurance, okay? Security assurance. Most of us know what the word assurance is, all right? I don't want to go into it, about most of it. So, but you notice that I had circled that one and this one, all right? Our focus area for this particular trading, all right? When I say focus area, what is in scope for us is vulnerability scan, then also security testing as well. Some job that you're going to be applying for, and I'm hoping that time will permit you, that will show you a few jobs. All right, some jobs that you're going to be applying for, you will see, they would be calling security testing, especially jobs that are related more to application, testing. They tend to use the word security testing as opposed to vulnerability testing. So that's why I've taken the time in this training to ensure that you're not missing anything, all right? Or you're not missing anything, and I'm also ensuring that everything is covered. Both network, vulnerability scan, then also bringing you back into application security testing as well. All right. So the word that covers everything is security assurance. Okay. So shortly we're going to be moving into classes of vulnerability. All right. There are ways that vulnerability are clashed. Okay. So we have, 3 classes, or maybe 2 classes. So we have what we call publicly disclosed vulnerability. We have another one that we call undisclosed vulnerability. All right. So it kind of explains itself. This is the most common class of vulnerability, which is the publicly disclosed one. They are known within the security community. They are usually assigned a unique identifier. I want you to note that word, unique identifier, and patches or fixes are usually available. So when a vulnerability becomes known in the wild, all right? So let me give you an example. Microsoft, all right? Microsoft, like I said, is one of the most secured operating system, okay? I'm not anything against Microsoft. We all use them. I have a laptop running Windows, but it's not just a very, very secure piece of software. All right. So every time that Microsoft identifies a vulnerability, they have the responsibility, all right, to inform the security community, all right, about that particular vulnerability. They have the responsibility to do that. And once that is done, there is a database that we call the National Vulnerability Database, where the information about that vulnerability is now stored. All right. For you, the security practitioner, you can go there and go and have a look and get an idea of what that vulnerability is, the severity level, and also, when it was first recorded, and what, the vendor is doing about it in terms of the fixes. All right. So those are publicly disclosed vulnerability. I think vendors have the responsibility, all right, to inform the security community if there's any weakness in their product, all right? The other one is undisclosed vulnerability. These are the 0-day vulnerability that we mentioned yesterday, all right? It's unknown to the vendor, and it is referred to 0-day vulnerability. This implies that the vendor has 0 day, no time to patch the vulnerability before it was exploited. And a typical example is the one that we talked about, yesterday, the most recent one, which is the log, 4JS. All right. So a zero-day vulnerability is a vulnerability in the system or device that has been disclosed, but it is not yet patched, all right? So the log J4S was disclosed, actually. It was all in the wild, all right, saying, yeah, blah, 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 but there is no patch for it. There is no remediation, all right? Hence, it is called a 0-day because they are discovered before the security researcher and software developer they have become aware of them. And before they can issue a patch, a 0-day vulnerability poses a high risk, to user, all right? For the following reason, cyber criminal race to exploit this vulnerability, to cash in on their scheme. Vulnerable systems are exposed until the patch is also released as well, all right? So 0-day vulnerability are those ones that keep most CIOs, or CISO awake in the night. All right. Then we also have what we call the bug bounty program. So this is a program where security researchers are rewarded, for their discoveries. All right. So likes of, Microsoft, big vendors, IBM, all right, big software or application vendors. All right. They, engage in this kind of programs. All right, where ethical hackers sometimes they pay them to do research, to find out, to try to break the application or try to circumvent their application and see if they could make any discoveries. All right, and once all discoveries are done, then vendor can start to work on the discoveries to make sure that they fix the issue. So through this program, researchers or entities are encouraged or even challenged to analyze the lines of code for critical flaws. All right, so most organizations engaged in this. All right, let me now take you back to, we understand disclosed and undisclosed. We understand the place of national vulnerability database. We understand why we understand now 0-day vulnerability as well. Let's look at what we call the adversary opportunity. All right, so let's look at what the adversary opportunity is. All right. So for you, a lot of times, when you get employed in an organization, all right, you are defending, your organization. All right. You are not an adversary. All right. You are acting as a defender. I want you to pretend, that you are in a football match. All right. If you're playing behind, just right in front of your goalkeeper, what you're essentially doing there is, you're protecting, your opponent, from gaining access, to your goalkeeper, to your own goalkeeper, or to that, box 18, you're pretending them, so you are a defender. All right. You could also be called an enterprise defender as well, because you are defending your organization against, cyber criminal, in other words, that we call adversary. All right. So if an adversary decides to attack your organization because of what they will gain, what would make that attack possible, is what we call opportunity. All right. So if you look at this illustration that I have here, very good illustration. You have the means, you have the motives, you have opportunity, and we also have attack realize. All right. So we have the plus sign here. All right. For cyber criminals, with their adversary to your own organization. All right. When we say the means, what we're essentially saying there that, their skill set. All right. Their skill set. So some cyber criminals, all right, they are programmers, all right. They can write programs in Java, they can write programs in Node.js, they can write, or they know React. They are very, very clever people, all right. So the adversary, they will possess the means to attack when he or she possesses the capability to successfully execute an attack. And for you, to successfully execute an attack, it just simply means that, you have certain means, and that means could be your skill set. All right. Then the second one is what we call the motive. All right. The adversary possesses the motive to execute an attack when he's willing to attempt the attack given the opportunity. The motive means that, they are willing, to attack your organization. Motive could also mean that, you remember archivists. We said archivists, what drives archivists is more of revenge. All right. Cyber criminals, hackers, their main, what drives them, or their motive, is more of, the monetary gain, what they would gain from the attack. All right. And, when they deploy, not deploy, when they, install it ransomware on your computer, what they ask in return is payment in forms of Bitcoin or some other stuff like that. All right. So they are motivated, all right, by what they would get or they would gain, from hacking your system. All right. You understand the means, you understand the motive. The means is their skill set. The motive is what is driving them, to want to hack your system. All right. But they also have, there's also in this equation as well, you will see the opportunity there. All right. So among these three, all right, these three constant, the only thing that you as an enterprise defender that you can participate in is the opportunity. All right. So you see, when you carry out scanning of your environment, whether you do internal or external scan, what you're trying to do as much as possible is to take the opportunity away. All right. Because if your environment, have anything that is fundamentally wrong with it, i.e. maybe there's a security hole, i.e. maybe, patches has not been applied, then there is an opportunity, for cyber criminal that is highly motivated, with the right means, to commit, or to attack your organization. So as an enterprise defender, someone that has been employed as a vulnerability management specialist, is the opportunity that you're taking away part-time when you're carrying out a scan. But where all of these, this constant or these variables, all right, are there, all right, then where the motive, where the means, where the opportunity is, then cyber criminal can actually, actualize, an attack against your network. All right. So I've already explained this. So what an enterprise defender will do yourself, what you will do is you're constantly taking that opportunity away. All right. So you will know your IT environment better than the adversary. They should make best use. You should make best use of the advantage of identifying and remediating exploitable vulnerabilities before the adversary, the cyber criminal, is able to discover and exploit them. That's exactly. So if you walk into an interview and they ask you a very complex questions, all right, you could say, listen, I'm a cybersecurity defender, whilst you cannot get into the head of the cyber criminal, all right, you cannot take their motivation away. That one thing, or one weapon that you have is to constantly, reduce the opportunity or take the opportunity away from them part-time. And what do you do? By ensuring that you identify, the weakness in your system and fixing those vulnerabilities, before, attackers, take advantage of it. All right. Common vulnerabilities and exposure list. All right. This is very, very important. All right. The CVE is what we call the common vulnerability and exposure. It is the unique identifier, for all vulnerabilities. You remember earlier on, I was talking about National Vulnerability Database. All right. Tony or Alex, if you do not mind, the link to National Vulnerability Database, if you can just post it in the chat box, that would be great. Okay, please. All right. So it is a unique identifier for all vulnerabilities. So vulnerabilities that are, disclosed. You remember we're talking about disclosed vulnerability and undisclosed one. All right. The moment vulnerabilities are identified, whether it is directly identified by the vendor, all right, or is identified by, the bug bounty hunters, or it's identified and it is reported, all right, to the security community. What the security community will do immediately, all right, is they would give a unique number, all right, to that vulnerability. So every vulnerability that's ever been recorded, all right, well, maybe ever been recorded or reported, a unique number is given to it. And that unique number is the CVE, all right? So you could liken that unique number to your national insurance number here in the UK, all right? The UK government, will give a person, an NI, all right, their payee so that they can contribute to HMRC. So NI is tied to the human being, all right? The same way the CVE, all right, the CVE is also tied, to every vulnerability that is reported. So CVE enables security communities to manage vulnerability. The CVE has, a certain format. And if you look at that format, is the CVE. You can look, this is the format I'm talking about. CVE, then the YYYY is the year, then the NNNN is the number. So YYYY is the year, and when vulnerability was publicly disclosed. All right. So every time you see a CVE, you would have the number 2013, 2018, 2019, 2020. All right. So that 2019 or 2018 just tell you the age of that vulnerability when it was first, disclosed. All right, is the age of that vulnerability. You can see here, publicly disclosed. All right, that is the age. Then the number represents the sequence number of the vulnerability for the year. All right, so but you see, the year is very, very important. I'm going to be talking about that importance shortly. All right, so the sequence number represented for 4 or more digits. Leading zeros are introduced in the year part of the in the early year of the in the early part of the year, while the first few IDs are also assigned as well. Why those numbers are very, very important? You see, the year is very, very important. Remember yesterday, I was teaching you about the criteria that you use in prioritizing, what vulnerabilities, to fix. All right. Do anybody remember that? Do anybody remember the criteria? If you remember the criteria, tell me. Tell me one criteria that you remember. Let's test your knowledge. Guys, tell me one criteria that you remember. Criteria for prioritizing vulnerabilities. What are the criteria? Do you remember any one of them? Yeah, severity, asset classification, Jacob. Age, yeah, someone say age, severity, age. Yeah, Olanike, yeah, I remember, yeah, that's good. Any other one? Jacob, it's not asset, well, asset classification and criticality. Yeah, so yeah. Any other person, any other one? Exploit. Yeah, thank you for that, Babatunde. Oh, right. So what we're saying here is the age is one thing that you put into consideration when you want to prioritize, the vulnerability that you want to fix. And do you know why that age is important? I'm glad that, Babatunde mentioned something around, exploit code. All right. So the longer the age of a vulnerability, the possibility that the exploit code is in the wild. The longer, the age of a vulnerability, the possibility that the exploit code has already been found by someone, all right, and it has already been used. So if you go into an environment, so please listen to me, this is very important. If you go into an environment and you do a scan, all right, and you find, vulnerability going back like 2013, all right, work it out now, 2013 to 2022, all right, it's about 9 years, you know what I mean? Yeah, 9 years, okay? Or it goes back as 2010, and you scan the environment and you see 2010 vulnerability, that's scary. So it means that, they've not been applying patch, all right, in that environment, okay? On the basis of that, you could recommend for the business to prioritize, vulnerabilities that has, such age, older vulnerabilities. And if someone argue with you and say, Babatunde, why should we bother? You could say that possibility that the exploit code, for this vulnerability could be somewhere in the wild. All right. So we cannot afford, because if someone has used that before to hack a system, then it's important that, we quickly fix this problem. All right. So I'm glad that, you brought that up, Babatunde. But do you understand me, guys, from that explanation, age and exploit code? Do you guys understand? Okay. All right, so let's move on quickly. Yeah, let's move on quickly. All right, so naming convention. So everything I've just told you now, you can see here, 2016, 2013, 2015, all right? I'm more particular about the age rather than the number that follows. The number that follows is important as well, but for me and for you as well, focus more on the age as opposed to, remembering all the other numbers, all right? So I'll move on quickly from here. Scoring system. All right, we also have what we call the CVSS, which is the Common Vulnerability Management, so Common Vulnerability Scoring System. All right, so for every time a vulnerability is identified, whether publicly disclosed, and it is recorded, all right, in the National Vulnerability Database. Just to let you know that the National Vulnerability Database is managed, by NIST. All right, NIST. NIST, all right? Alex, if you do not mind, the website to NIST, if you can just whack it into the group, that would be great. It's managed by NIST. So NIST is American, and NIST is a non-profit organization. So the government fund them, actually, all right? They manage that database, all right? So they also help with the scoring system as well. So every time that a vulnerability is reported, all right, that vulnerability is scored, all right? So that's why, scoring could be, you could hear that some vulnerability scoring is critical. Another one is high. Then we have the medium one. Then we also have, the low, severity level vulnerability. Obviously, it's no brainer. When the criticality level, when the scoring is critical, then in terms of the severity, usually organization, we tend to prioritize, the critical vulnerability against, others. All right. Again, it takes us back to, what are the criteria for prioritizing, vulnerabilities to remediate or fix. So earlier on, we gave the example of the vulnerability age. We tie it to the exploit code. Now, severity could be another one, or could be another reason, for fixing vulnerability. All right. So the de facto vulnerability scoring, which provide a way to capture the main characteristics of vulnerability, produce a numerical score that reflects the severity of certain vulnerabilities. All right. So the scoring is based on several factors. And among these factors is, number one, the scoring is based on several factors. Among these factors is, number one, how easy, is the vulnerability, how easy could the vulnerability be exploited? All right. So it's one thing, for you to identify vulnerability, is another thing for that vulnerability to be exploited. Remember when I taught you the concept of the house, when we gave the example about Tony's house, that we realized that Tony's door, the door that leads to Tony's house, that big mansion, is left ajar. All right. So from outside, you could take a peep and actually see, that the door was not locked. But we said something that chances are that Tony could also have that extra layer control inside the house, that kind of lock or chain that you use, to further close the door beneath it. So if you apply a force, to that door, the door will not actually open because there is an extra layer of control, physical layer of control inside the property itself. All right. So not all vulnerabilities are exploitable. That's the point I'm trying to make. So what the scoring system actually does is, before they score any vulnerability, they look at, is it exploitable? All right. How easy is for anybody to exploit that vulnerability? All right. Then number two, what they also consider is how long, how long that vulnerability has been around for. All right. That is vulnerability age. How long has it been around for? Okay. How easy can you exploit that vulnerability? All right. So they combine so many things, and we're going to be going into that, shortly. All right. So So I want you to take note of those two, all right? The scoring criteria, all right? The exploitability of the exploitability of the vulnerability. Number two, how long, the age of that vulnerability. I'll give you more examples pretty much later. All right, so I want you to take your focus back here now. The CVSS scoring can be up to 10, all right? The highest being 10, all right? All right, 10 being that the vulnerability severity is high or it is critical, all right? And it could be easily exploited. So when you see a vulnerability scored, 10, what CVSS, the interpretation is this particular vulnerability, pay attention to it because of the scoring, because it can be easily exploited. You see, don't forget that the scoring is done by an independent body. So if Microsoft, for example, all right, releases, or let, the security community know about a particular vulnerability, it is not Microsoft that will score the vulnerability. All right, the scoring will be done by the security community, which is led by NIST. All right, they are the one that will score it, not Microsoft. So if NIST come back to us and said, oh, for this vulnerability, it is 10. So, they just want you to give your attention, your utmost attention to it, because it can be easily exploited. All right. The CVSS system offers several benefits, all right, to an enterprise defender. I'll be showing you a few things in the next slide. So do you understand my explanation? Do you guys understand my explanation? I hope I haven't confused you. Thanks, Alex. Do anybody else understand it? Abdul? All right, you understand my explanation? All right, I'm glad that I wasn't speaking gibberish. Thank you, all right, for showing some faith in me. All right, let's move on quickly. All right, so there are three metrics, all right, that NIST actually now use, all right, to do, their scoring. So there's one that we call, there are three approach that they use, for their scoring. There's one we call the metrics-based, scoring, or what we call the matrix, the matrix group. Then we also have another one that we call, sorry, I got it wrong there. So there are three metrics that they use. There's one that we call the base. There's one we call, the temporal. They also we call the environmental. All right, the base, the temporal, and also the environmental. All right. So the CVSS is made up of three matrix group, namely the base, the temporal, and also the environmental. I would tell you what is important. It's good for you to understand all of this. Okay. But in all of my years, in cybersecurity and where I've done, vulnerability management, so you don't go around and be explaining all of this base and temporal and environmental. All right. When you're actually doing the job, what is important is, when you pick up the report and you look at the scoring, you want to swing into action as much as possible. All right. But, it's good to understand this matrix group. Okay. But don't spend too much time on it. All right. I think that's the point that I'm trying to make. I would rather learn what it is and how to do the job rather than, the theoretical aspect of it. All right. So what is base? The base matrix group represent, the fundamental characteristics of vulnerability that are consistent over time. That is the base. All right. So you could look here. So you can see here, CVSS scoring matrix, the base, the temporal, and the environmental. But what the base is all about, all right, it takes the fundamental characteristics of a vulnerability, and it will check whether that fundamental characteristics is consistent, consistent over a period, across multiple user environment. All right. It will check the characteristics of the vulnerability, all right, and check whether it is consistent over a period of time, and across multiple environment. When I say multiple environment, so you would agree with me that your environment are different. So people that are working in manufacturing, their environment is slightly different, all right, to if you work in oil and gas, all right, the environment will be slightly different. Or if you work in maybe with NASA or something like that, slightly different environment, okay? Slightly different work environment. Maybe the piece of software, the type of computer, and how their network, is, will be slightly different. That's what we mean by, multi-user environment. So what the base is all about is when they are doing this scoring, they put these things into consideration. The characteristics, of the vulnerability, whether that characteristic is consistent over a period of time, across multiple environments. So they will test it across different environments. All right. The base also composes of, two elements. All right. It composes of what we call the exploitability matrix and the impact matrix. All right. The base is made up of that. All right. So you can see in here, all right, exploitability and also impact matrix. Don't forget, generally, all right, we said CVSS, all right, when scoring is done, it considered two things, all right, exploitability, and number two, if you still remember it, I said number two, the age of that vulnerability, okay? But if you now take it further down to the base, the temporal, and also the environment, the matrix is based on exploitability and also impact. All right. So the exploitability now, they look at what we call the attack vector, attack complexity, privilege required, user interaction, scope. Impact talks about compactability impact, integrity impact, availability impact, and also the scope as well. I would explain this shortly. Do you understand what exploitability is? Let me see if you understand that. If you're struggling with that, then any other thing that I say will not really make a whole lot of sense. Do you understand what exploitability is? From the concept of the house that I shared with you, you understand it, all right? You understand exploitability, okay? Jacob, all right. I want other people to talk, because I noticed that people that are consistent across Tony, Jacob, Kazim, okay, Toib, nice one. Other people now, let's see if others understand it. Jamel, thank you, Jamel. Any other person? Encourage me now. Okay, someone said no. All right, wait. Someone said they don't understand. I'm particular about the person that says they don't understand. Okay, so this person is, I can't pronounce your name. Bugo. Unye something. Okay, right, sorry. Can't pronounce your name. Okay, so it's the only person that says it doesn't understand it. Okay, so let's see. Okay, Bugo. All right, okay. All right, I would explain it one more. All right, I don't know, I think I'm seeing you for the first time. I'm not sure. Okay, I think I'm seeing you for. Okay, let me just explain a little bit more in terms of the exploitability. All right, so I want you to, Bugo, I want you to think about where you live. All right, where you live at the moment. Oh, your first time. I see. All right. Okay, your first time. My first time. Okay, I would just try and explain it. I would excuse it and just try and explain it. All right. So think about where you live at the moment. I don't know where you live, whether you're in Africa or in this side of the world. All right. Oh, let me use this. Let me use this example. Your car. Let's say you drive one of the modern day car. All right. And you realize that you did not lock your car. When I say lock your car, you didn't lock it. Most of the modern day car, we have the Bluetooth car keys that we use to shut our car down. Your car is locked and all of that. Okay. Let's say, and most of the cars, they are keyless. They don't have keys. You know what I mean? All right. Is the car that I use now is the one that you just, start and, you start, once you get into the car, you can press the start button, put your leg on the pedal, and the car will start. Okay. Let's say you use one of those cars. All right. And you left the car in a door unlocked. All right. So we can say your car is vulnerable. All right. It is vulnerable to maybe a theft. People can steal the car and all of that. Okay. But the modern day car, all right, by reason of how they are built, you must have the car, the key to the car, all right, maybe right in your pocket or somewhere very close to the car before you can move the car. All right. Okay. Before you can even move the car. So assuming that your key is far away, but somebody is able to open the car door. All right. We already said by reason of the car being open or the door not being shut, it is vulnerable. All right. I want you to understand that it is vulnerable. But you see, whoever wanted to launch an attack to steal the car, even if they open the door, all right, and they do not have the key closer to, at some level of proximity to the car, they will not be able to move the car. All right. So the point that we're trying to make there is, despite that your car is vulnerable, all right, exploitation, all right, or exploiting that vulnerability might not be possible. All right, does that help you? All right, because let's just help this gentleman. Does that explanation kind of help you? So despite that your car is vulnerable because the keys, because you do not lock the door, exploiting that vulnerability by someone, that has malicious intent might not be possible because they do not have the car. The car key with them. Just bear with me, guys. All right, so sorry about that. Okay, so that's another way of explaining that exploitability. All right, so what we're saying for base is they use this matrix, all right, that I'm putting my cursor on, to determine the exploitability. All right, so what they are saying essence is, we're talking about the scoring now. So they're using two metrics, exploitability and impact. But for all of the exploitability metrics, they're saying that for you to be able, even if an asset is vulnerable, all right, for you to be able to exploit those vulnerability, each of these things is what they will consider. They would consider whether, the person that wanted to exploit that vulnerability requires a privilege, whether in a privilege requirement, whether it requires certain privileges. Let me give you an example. Let me give you an example. I'll give you an example of a house again. Please follow me carefully. So Tony's house, the door is left open. All right. Let's say now that the extra layer control behind is not there. All right. So this person, the thief, has gone into the house. But you know the way houses are built. So if you come into the house, there are doors for each rooms. You know what I mean? So if it were to be a shared apartment, all right, everybody would have keys that they use to lock, each of their rooms. So if you make way into the hallway, all right, if you're able to get into the hallway, you may not necessarily be able to get into each of the rooms. All right, are you guys following me? Please, it's important. I wanted to explain this. You may not necessarily be able to get into each of the rooms because each of those rooms might be locked, by their owner. all right, but yet you're able to get into the main house, maybe the common area where people is, maybe the kitchen area. All right, the door is open, all right, you've been able to make your way, but to now exploit, all right, each of those rooms, it's not possible because you will need a key. That is what privilege is all about. All right, in network, okay, someone can hack your network. They can hack your computer system, all right? But when they hack your computer system, they might need certain privileges to be able to access your hard drive. So if your hard drive is encrypted, they will now need to decrypt, all right, your hard drive, to be able to access it. Do you understand what I'm saying? If you logically partition, all right, your drive, and for each of the drive, you have attached a username and password, to protect it. That individual would have to have a knowledge of the username and password, to be able to enter into each of the drive. That is what privilege, is all about. So they are saying here that for this exploitability metrics, the scoring, for you to have that scoring of that person would have, they would require privilege, to be able to exploit that vulnerability. This one says users interaction. So it means that a bot may not be able to exploit that vulnerability. An individual, human being, would have to physically interact, with the asset or the control to exploit this vulnerability. Attack complexity. So they were talking about that, for you to be able to exploit this, the complexity, might be high or will be low. So that is what this explanation is all about. Then they also moved to the temporal one as well. They said for this one, the exploitability code maturity. Let me take you to. I know this one might be a bit difficult for you to understand, but all right, I've already talked about this one. All right, so for the temporal matrix group, characteristics of vulnerability that are consistent over a period, but not across, across user environment. All right, it is consistent, but not across all. It said the presence of ease, to use exploit key, increase in the temporal attribute of a CVSS scoring, and hence it's over scored. All right, it's over, overall score. Say conversely, the creation of an official patch would decrease the temporal attribute of the CVSS scoring and hence its overall score. All right, so this is another matrix group. But if you go in, I'm still going to show you National Vulnerability Database later. We'll just take one CVSS and I will show you to you. All right. So if you look at this score, the matrix that is commonly used these days, all right, is the base matrix. All right. And it's just because of this combination, all right, of this exploitability matrix and the impact that is used. So it is most commonly used now for the scoring. And I think the most recent version is version 3.0. All right. So NIST all the time, do all of those conversion and, they give it a number. All right. So why this is important for you to know or have an idea of what it is. But to be honest, when you start to work properly and you start to work in this kind of environment, it becomes less. It's not something that, imagine if you have thousands of vulnerability, you don't go around and be looking at, what is base and what is, temporal matrix and what is environmental matrix, maybe except if you're writing an exam, you know what I mean? Okay. It is good to know, to understand how the scoring is done, but at work, you will care less about how the scoring is done later, because if your house is burning, to be honest, you just want to make sure that you put the right controls in place and quench the fire as much as possible, rather than trying to find out, oh, how did the fire start? Okay. So this is good. So the temporal one, we also have the environmental one as well. The characteristics of vulnerability that are relevant and specific to an IT environment. Scoring of this matrix is inversely proportional to the presence and the effectiveness of the security scoring, the security control implemented in a particular IT environment. Again, a lot of talk there, but your focus should be more on the base matrix. And the latest version is version 3.0. All right, when we get the time, I will show you. I will show you a sample. All right, so what is the difference between both of them? One, talks about is a unique identifier. The other one, no brainer, it talks about the scoring. One is a unique identifier. CVSS is the scoring. The other one, is just a unique identifier. All right. So let's look at some types of, vulnerability scanner. All right. So what is a vulnerability scanner? A vulnerability scanner is an automated vulnerability testing tool that monitors for misconfiguration. I defined earlier on to you, what security software vulnerability is. We talked about the fact that it is a bug, in a code. It could be a it could be a misconfiguration. It could also be a security gap as well. All right, remember that one. So what security tool it's all about, or a scanner will do, is it would monitor, a piece of application for misconfiguration. It would monitor a piece of application for code flaws or flaws in the code, that could possibly pose, cybersecurity threat. So vulnerability scanner either rely on database. All right, I want you to note this one now. It relies on a database of a known vulnerability. So that now brings us back to our national vulnerability database. It brings us to our national vulnerability database, because for every time a scanner is working, a scanner is making reference, to a database somewhere. So if a scanner does scan your environment and it picks up certain vulnerability, all right, it goes to the national vulnerability database, to compare it, and it will now give it the appropriate scoring. As a matter of fact, your scanner is not the one scoring the vulnerability. The vulnerability has already been scored because they are known vulnerability. That's why scanner does not pick 0-day vulnerability. Does that make sense? I hope I didn't confuse you there. Known vulnerability, publicly disclosed vulnerability that are known. They are stored in the database. When your scanner scans your environment, it identifies the vulnerability, all right, but the scoring, it can relate it, to the national vulnerability. But if they were not, if there are vulnerabilities that are not known, the scanner will not report it. So you can see that the scanner has some limitations as well. It won't report it because it doesn't know them. It only reports what it knows based on signature that we're teaching you yesterday. So the scanner will log defect vulnerability and sometimes assign a risk score. So the scanner will assign a risk score, but the scanner does not, score the vulnerability. The score, because the vulnerability has been independently been scored, all right, by the security community or by NIST. Okay, is this making sense to us? I hope I'm not. I'm just trying to build a relationship. I'm just trying to build a relationship, making sure that, I compare, not compare, but make reference to the database that I've just mentioned, which is the NVD, all right, and what a scanner will do. All right, okay, so Ike says, yes, you're getting it. All right, is there any other person getting it? Is there any other person getting it? All right. Okay, Abdul says, Abdul is an A student. Even Patrick Banji says yes as well. All right, okay. So I'm glad you're getting it. But don't be shy if you're struggling, let us know. All right. Okay, so we get that. But what the scanners, what vendor has now done is, so they also do, they have created their product to now be able to do risk scoring as well. All right, risk scoring. So the fact, so you could have severity level 10, they could now further now score that risk, based on certain other criteria that, they have picked up. I would explain how that risk scoring work much more later. All right, and please, if I do not explain it, remind me. All right, I know some of you remember a lot of stuff. Remind me towards the end, so that while you said you would explain how that risk scoring work. So let's just move on quickly. All right, so how are vulnerability scanner, how are they categorized? All right, how are they categorized? So scanners can be categorized by the following operational model. All right. There are different types of scanner, but they are categorized based on certain stuff. Let me show you this. Maybe this will make a lot of sense to you. So there are 3 common type of, scanner, all right, based on category. So there is what we call the network vulnerability scanner. We have some scanner that does web application scanning as well. Then we also have what we call open source vulnerability scanner. All right. So before we have open source, we have always had network vulnerability scanner. All right. So it's the one that will go into our network and it will scan all of our network. Let me even give you the description of what it is. So a network vulnerability scanner will monitor the web server. All right. So all of your server and network will do that. The operating system, they will scan your routers and your switches. They will scan your firewall as well. A network scanner will do that. They would also, check all of the daemons and other services open to the internet, such as database services as well. A network scanner will do that. Network scanner work against a database of a known vulnerability. You can see that again. They're always making reference, to that big database of a known vulnerabilities. Many of these databases will rely on the common vulnerability exposure, the unique identifier that I mentioned earlier on. All right. Program-free and comprehensive catalog of known software and firmware vulnerabilities. All right. Each standard record comprises of unique, CVE identifier, a brief description, and also at least one public reference. All right. It will comprises of that. So Alex has, he did us a favor. What Alex did was, I think he posted the link. Please click on that link and look at it. We'll talk about it pretty much later. So I want to move quickly so that, we'll have enough time, to take questions. All right. That is what a network vulnerability scanner is. We also have the web, scanner as well. So web scanner can scan application, website code, to find vulnerability that, compromise the application or the website itself or its backend services. They are an extension component of application security testing. All right. So web application vulnerability scanner is an extension component of application security testing. So this scanner will work against a known list of common exploits as maintained by OWASP. All right. Do anybody know OWASP here? Open Web Application Security Project. OWASP. Anybody, guys? Do anybody know OWASP? Anybody? OWASP. No, okay. It's called Open Web Application Projects. Alex, do me a favor. Can you put the link there for them? Oh, the link was posted by Alex. Okay, so OWASP is, so if you think about all the possible exploit, so they're also a de facto standard around de facto standard, for application security or mobile, application security, including web and mobile. All right. They are the de facto standard for that. So anything that you want to learn about security, all right, about common exploit in web and mobile application, OWASP is that reference or point of reference. Okay. So please, if you do not know them, you can learn it a little bit. All right. So this exploit use various injection and evasion techniques to hijack web services or website in order to exfiltrate data, to trick users or systems into providing sensitive information, or to disrupt application performance. Some of the better known exploit are SQL injection, cross-site scripting, man-in-the-middle attack, and also malicious code as well. All right, so we have web application scanner. All right, so which one do we have again? We have what we call open source vulnerability scanner. All right, what does this mean? So the open source vulnerability scanner are software, composition analysis. Some of you must have heard about software composition analysis. If you haven't, these are some of the takeaways, to be honest, to look at. So there is a particular tool that you can also use to scan your application to discover open source framework and libraries. So has anybody heard about GitHub? GitHub? I'm sure my brother will just be like, oh, what is all this? Has anybody heard about GitHub? All right, GitHub. All right, yes, okay. So if you have heard about GitHub, for example, you would, GitHub, there's always this, open source libraries, frameworks that are there that, developers go there, they use it, all right? And they even use it for coding. Sometimes, people group and, so you have different libraries that are there that people use. But while you can use that, we're saying that you also need software composition analysis tools, all right, to be able to discover, if your source code is using any open source framework or libraries, all right, that has any direct or indirect dependencies, all right? So you need, a scanner that would help you to identify if those libraries, have some specific vulnerabilities, all right? So if you're coding, your developers are doing some coding for you, make sure, that you're also scanning the libraries where it is being used or where things are being developed to ensure there is no any backdoor of vulnerability, all right, that cyber criminals can actually take advantage of. All right, let's move on quickly. Then we now have these ones that you can see here. They are all different kinds of network, stroke application, scanner. All right, a mix of network and application scanner. All right, some of them are quite prominent. We have Qualys. All right, Qualys is a vulnerability management scanner. It helps in identifying, addressing security threat through cloud-based solution. Even the network auditing can also be automated using Qualys as well. We have Nessus. Nessus has also been around for a while. All right, so Nessus is a patent and also a branded vulnerability scanner, which is developed by Tenable Nessus Security. This tool has been installed, and used by millions of users throughout the world for vulnerability assessment and also configuration issues as well. In some organizations, they combine both. Remember, we said there is no one tool that is perfect by reason of false positives. Some organizations would have both Nessus and also Qualys. Some may combine Nessus with Akinetics. Some may combine Qualys, with Rapid7 and all of that. All right. So these are examples of different scanners that you can use. Some scanner can also be open source as well. All right. When a scanner is open source, it means that, like OpenVAS. All right. So OpenVAS, this particular one. All right. OpenVAS, serve as central services that provide tools, for both vulnerability scanning and vulnerability management. OpenVAS services are free of charge, all right, which is an open source, and generally licensed, under the NGA general public, license as well. So you could use the community version. You could also use the license version as well. These are just examples of different scanner. They are much more than this, to be honest. And this can be used as both as network scanner, and also they can also be used, as a web application scanner as well. All right. So does vulnerability scanning works? Pretty much simple. This is high level. All right. I don't want to take this away and just say you understand everything. High level, but when you come for the real thing, obviously we'll show you more than this. All right. So number one, it starts with general. This is how general scanning, how it works. All right. Number one is it starts with detection. All right. The first step of vulnerability assessment tool is to conduct a vulnerability test for detecting and also identifying possible attack surface. All right. It enables you to determine the security gap across your network and fill them with attackers can penetrate it. The second step is to classify. In the second step, the vulnerability are classified to help admin prioritize their action. And the top, very high level. That's why I'm saying this is very high level. All right. It's much more deeper than this. The third step is the remediation. Generally, vulnerability scanner do not provide a way to remediate, identify vulnerabilities automatically. They are focused more on monitoring and also providing details of the admin, to take their further steps. So they would make recommendations in terms of how to fix the vulnerability. It will tell you that maybe a patch, is missing, and it would, some vulnerability management solution, it would give you exactly, what the patch ID is and where you can get the patch, but again, you have to do all sort of analysis, against that recommendation to determine what to do. All right. They will make recommendations of the fixes, but the vulnerability scanner itself will not apply the patch for you. All right. So how do you perform vulnerability scan? You define the scope, you create a standard procedure, you identify types of the scanner you needed, you configure the vulnerability scan, you evaluate associated risk, you would initiate the vulnerability scan, analyze the result, then create a remediation plan. All right. Again, this is very, very high level in terms of how you can perform your scan. It might vary from organization to organization, but if you look at each of those items and across the steps, they are consistent in terms of what you would do from start to the end. All right. When we say you define the scope, in other words, we're saying is identify all the assets in your organization that you wanted to scan. All right. You must identify the asset. You must have the asset name and also the IP addresses of those assets. All right. You must create a standard procedure. All right. So procedure just simply means that you have a structured methodology of the vulnerability scan, how you want to carry out the scan. In some organization, you could even have a policy, a procedure, and also processes as well. You would have vulnerability management procedure that clearly define the objective of your vulnerability scan, all right? And also how you will carry out, the scanning, itself, all right? You must identify the type of scan needed, all right? In some organization, do you want to carry out internal scan, or do you want to carry out external scan? And what is the frequency, that you will carry out the scan? The frequency would, clearly will be communicated, in your policy. All right. You have to tell, your customers, and your staff, why you're carrying out the scan and the reason why you have chosen the frequency upon which you're carrying out a scan. So that will be clearly communicated in your, vulnerability management policy. All right. You also have to configure the vulnerability scanner as well. All right. Address the configuration of the vulnerability based on the general objective that you want to achieve. Configuring the scanner is not difficult, because in itself, when you receive the scanning box, or whether it's a cloud-based solution, all right, it's most likely that it has already been configured, at least halfway configured. You're not doing any heavy lifting. You're just going in there, putting your username and password, or somebody's creating an account for you, because they are all pre-configured. To be honest, what you're just using the tool for is just to scan. All right, you're adding your asset to the scanner, and you're just one click away or the other to start scanning. So you're not doing a lot of configuration. If you take Qualys, or Nessus, for example, it's already been pre-configured. They create an account for you, you add your asset, and here we go, we start to do the configuration. Maybe you make it some slight changes, So for your reporting, you may want to customize your report. The templates are there, for you to select when you're customizing your report. Mostly what you're doing, when you have your scanner set up, is you are only adding your asset that you want to scan. And when I say add the asset, you're adding the IP address, to the scanner, address memory, that you want to scan. Evaluate associated risk. Yes, once you do your scan, you generate the report. It only just makes sense that you want to analyze the report, and you want to evaluate the possible risk. I said something earlier on. Some scanner like Qualys, can also quantify the report for you. Nessus can also do the same thing. I mean, a lot of all the new scanners, so other than the severity level of the vulnerability that you have identified, scoring, so risk scoring can also be done. That would also help you to prioritize, your remediation or the vulnerability that you wanted to, fix. Then we have, analyze the report, which I've talked about earlier on. You get the report and you start to look at, the severity level, so because that will give you an idea, of the entire security posture of your organization. Obviously, if you have a lot of criticals or highs, from in your vulnerability results, it tells you something, and it also gives you an idea what to prioritize for remediation. Then obviously you create your remediation, plan. Okay. We will take like 10 minutes break shortly. I'm conscious that we are. How many minutes are we into? How many minutes? We've gone far. Alex, How long have we been talking now? Have we been talking now? Are we over 2 hours? I'm not sure. 2 hours. Okay. All right. We would maybe take a short break when we are maybe 2 hours. Yeah, maybe when the moment we get into maybe 2 hours, 2 hours, 30 minutes, if that's okay. We'll take short minutes because we have to finish this today. All right. I'm not rushing, but we have to finish it today. All right. So we've already talked about type of scanning, external, internal. We also do what we call, the only thing I haven't talked about is the environmental vulnerability scan. They are based on specific environment of the enterprise technology operation. These vulnerability scan are specialized and also are available to deploy multiple technology, such as IoT, website, cloud-based service, and also mobile as well. So some environment, depending on where you're working, can be quite sensitive actually. So if you're an e-commerce website, not e-commerce, whether you process a lot of cards on behalf of your customer, the way that your network would be ring fenced, especially where those sensitive information are, all right, for your customer. Of course, PCI DSS mandate that you must segment your network, all right? And if that is the case, that you have segmented your network, particularly for areas where you have sensitive information, all right, you could also do an environmental scan as well, specifically for that area, all right? So that's what that environmental scan is all about. It's not different from the standard scan, it's just that, for that particular, area where you have sensitive information, maybe the frequency at which you want to scan that area is different, or maybe you want to use a special scanner, all right, to scan that particular, but the concept of scanning is the same thing, all right? So I don't want you to get it all. All right, so scanning method, we have what we call the intrusive and the non-intrusive. I touched on this yesterday slightly. The non-intrusive just identify vulnerability and generate a report, for user to fix. If a non-intrusive scanning method is used, no actual vulnerability exploitation occurs. All right. So when you hear non-intrusive, it's just saying that we have not exploited the vulnerability that we have identified. All right. So that's all about non-intrusive. But intrusive is the opposite. All right. Intrusive just means that you have attempted, to exploit the vulnerability after they are discovered during scanning and an attack plan is created. All right. But generally, all right, in the real world, most of the scanning that we do, they are usually non-intrusive. All right, remember I was teaching you yesterday that penetration testing can be intrusive. All right, if you intrude in something, all right, the chances that you might break the system is possible. Nobody wants that. All right, so you do less of intrusive scanning. All right, you do more of non-intrusive scanning. The benefit of intrusive scanning or method is that the scanner will highlight the security risk as well as the impact of the exploited vulnerability. On the other hand, this scan can disrupt processes, like I said, and operational system in the network. We can actually cause issues for both the customer and the employees of that organization. So therefore, intrusive scanning should be used with caution. All right, it should be used with caution. So I want you to think about a non-intrusive vulnerability scan as non-credential scanning, all right? Non-credential or non-authenticated scanning. But opposite is for the intrusive. Intrusive can be considered as, credentialed or authenticated scanning, all right? And what does that mean, all right? So authenticated versus non-authenticated. In other words, credentialed and non-credential scanning. So unauthenticated scan, it would explore, it would detect services open on the computer over a network by sending packet, to an open port. It usually determines the version of the operating system, the software version behind the respective services, open files shares, or any other available information without authentication. So if you're using Qualys, if you're using SAT Nexus,
if you're using, not SAT-Nexus, if you're using Qualys, if you're using Nexus, all right, if you're using Akinetis or any other vulnerability scanner, all right, if you have asked the vulnerability scanner to scan an environment, all right, you have the option, to either tell the scanner, to scan unauthenticated or authenticated. Authenticated just simply means, which is the opposite, is you're giving the scanner a username and a password with certain privileges, to scan your system, all right? You would agree with me that, I gave you the example of the house, all right? Okay, so if the front door to your house does not have a key, all right, somebody can just walk in there, all right, and get to the kitchen area. That is an example of unauthenticated. They just walk in there. But listen, if they have to use a key, all right, and force their way open, they force their way, into the house, and they have a master key that can open every other door in that house, you could liken that, to authenticated scan. So what we're saying with your authenticated scan is you have to give, the scanner a username and a password to carry out scanning. All right, but that, we said you have to do it with caution, because if you're doing authenticated scan, chances are, you might break the system. All right, is this making sense to you guys? Is this making sense to you guys? All right. This is Qualys, for example. So we're going to be using Qualys as an example, but it's important that I quickly say this. This is not Qualys trading. All right, we're just taking Qualys as an example of a scanner. Qualys is different. If you come for the real training, then we're going to teach you a whole lot about Qualys. All right, but how does Qualys work? All right, so Qualys has a scanner engine. All right, there are different ways that you can deploy Qualys. I'm not going to talk about that deployment today because I don't want to confuse you. All right, there are different ways, there are different ways that you can deploy Qualys. All right, but let's talk about how Qualys actually work. All right, so the first thing that Qualys does, it does what we call the host discovery. All right, so if you're using Qualys, all right, to scan your environment, the first thing Qualys would do, it would first discover the host. All right, so you have said Qualys, so go and scan my environment. I have 10,000 assets in my environment, in my local area network. Go and scan it. Qualys will first go out there and discover each and every one of those assets. All right, it does the discovery, check. All right, it will check if, all of these hosts, this computer, servers, laptop, website, all of them, if they are alive. All right, being alive is, are they active? Are they reachable? All right, that is what Qualys will do, when it's doing what we call host discovery check. All right, then how does it do it? Qualys will send by default what we call TCP port 21 to 23. These are the ports that Qualys use. All right, apologies if you are not a network person here. All right, in vulnerability management, you have to learn a little bit about networking. All right, so you will hear me talking about IP address and all of that. All right, we're talking about ports now. For every port, there is a number. So when you browse your website now, www.smartlearning.co.uk, www.amazon.co.uk. So you see that amazon.co.uk that you are browsed, all right, is listening on port 80, all right? So every time HTTP, all right, is listening on port 80, HTTPS is listening on port 443, all right? Then we have also other port lights as well. 23 is FTP, no, Telnet. 21 is FTP, and you have so many port. 22 is SSH, all right? So you have port 53 is DNS, 25 is SNMP. You have all different port. 101, is it 101 or 110? Is POP. You have different ports across, okay? They are all listening. So what Qualys would do, Qualys would identify, all right, this host, if it's alive, and the port that is listening, per time, all right? Then what Qualys will do on the back of that is Qualys will produce a report, to tell you whether the host is dead or is alive, all right? Then it would also detect whether it couldn't reach the host because there is a firewall in between the host and itself. All right. The next thing Qualys will do is it will do what we call the TCP port scan model. All right. So once he has identified, that out of 1,000 hosts, maybe you could reach 800. All right. Then he will now take it further. It will do what we call the TCP port scanner. All right. It would want to scan the port. All right. For each of this asset that he has identified, what port is open if it can reach those ports. So you can see that we call it, host status, whether it is alive. Host can be reachable from the internet. All right. Tags, find all the port, open TCP ports. So Qualys will do that, looking for all the ports that are open. All right. Then it will now, it will produce, the TCP ports that are open. All right. So on the back of checking whether or not the host is alive, then it will do the port scan, which is followed. All right. Then after that is done, what Qualys will now do is to detect, all right, the operating system. All right. So it will check whether, the type of operating system that is running on this server, whether it's a server, whether it's a workstation or a desktop, it will figure that out. And in the process of doing that, it does what we call the OS, fingerprinting. All right, OS fingerprinting. So you see all these actions that you can see here that I said Qualys is doing, all right, per time to ascertain or to identify the vulnerabilities, in this system is an unauthenticated scanning. All right, it is an unauthenticated scanning, because what Qualys is doing is it wants to identify the operating system. It wants to discover, the TCP and UDP services that are, that are running. It wants to check, whether there are any known vulnerabilities in the operating system. So this is an example of an unauthenticated system. All right, just to let you know that, this is just an overview of what Qualys will do, when it's carrying out the scan. The ability of Qualys is much more than this. All right, it is much more than what I've just shown you. So just like I said, this is not a Qualys training. If you join the real thing with us, then we can show you some other stuff. So every other thing that I've just mentioned here is captured in these 6 steps. All right, check if the remote is alive. Check if there is a firewall in between, the scanner and the target host. Do a port scanning, TCP and UDP. Establish, the operating system that is running on the host. Do what we call TCP or UDP discovery. Check again. Then vulnerability assessment based on the services detected. Then it will now report back and say, all right, there is a vulnerability on the operating system, and these are the vulnerability. All right, let me move on to this one. This bit is again Qualys. Qualys is a vulnerability management piece of software. All right, Qualys is not just a scanner; it is a vulnerability management solution. So hence, Qualys has different types of modules. All right, so it has the scanner engine, but it also has so many other things. It has what we call the continuous monitoring. So this is a type of module. It has the threat protect. It has the policy compliance. It has the PCI compliance. It has what we call security assessment questionnaire. It has the web application scanner. It has the web application firewall. It has the malware detection. You also have what we call the asset view. All right, so Qualys has different, but when you buy Qualys, you're actually buying the vulnerability management solution, but you could buy all other modules as well. All right, all other modules. If you remember earlier on, we said, different categories of vulnerability scanner, and one of such scanner, is a web application, scanner. All right, so Qualys has, a specific module, all right, within the entire suite of products, that they called web application scanning. All right, so these are all the features and all of that product that comes with the vulnerability management. All right, like I said, this is not Qualys training. I'm just showing you all of the possibilities. If you want to learn more about Qualys, then we can show you a little bit more when you join the real thing. All right, let us take 10 minutes break. Is that okay, guys? 10 minutes break. Yeah, Jacob, 10 minutes break. All right. All right. So let's take 10 minutes break. And yeah, Alex, so if we take 10 minutes break, when are we coming back? Alex, can you advise? Alex, can you advise if we take 10 minutes break? When are we coming back? All right, so 21:20. All right, so we would come back here 21:20, okay? We would be back here 21:20. So if you're in Africa, maybe in Nigeria, you probably will be back here 22:20. All right, we must finish this stuff today. All right, so we must finish it. Okay, so 21:20. Head banging, man. Don't worry. Africa, 21, well, it depends if you're in West Africa, 22:20. All right, so I would take a quick break as well, to just get some water. Yeah, the recording is still going on. We have the recording. I can pause it. Let's pause the recording, but remind me to resume the recording when I come back, please. Okay. All right, so thank you. We're back now, and we will look at vulnerability assessment report. This is just to give you an idea of what it is. In the actual training, we'll perform scans, and you'll be able to see all of those score with the CVSS number, with the CVE number, with the CVSS, with a possible risk score, and all of those stuff. But this is just to show you very high level what is expected in the vulnerability assessment report. So let's, so a typical, just bear with me, please. Yeah, apologies for that. So a typical report will contain the discovered vulnerabilities. The deliverables is essentially useful for summarizing findings to the management, detailing findings and mitigation recommendations, and also tracking progress during the remediation process using Excel sheets. Like I said, if you're good with Excel, this would make a whole lot of sense. You could have different, you could get your vulnerability to be reported in different formats. You could have it in CSV, you could have it in XML. Yeah, you could have it in PDF. Usually you don't put, because if you have it in PDF, then you have challenges with, analyzing it or slicing and dicing it. So Excel being a very, very powerful tool, you can use it for to analyze your report. But I said, if the report is bigger, much more, if it's a large record, then Excel will just break down. All right. Then what a lot of organizations tend to do is they use more of Power BI. All right. I haven't used Power BI before, to be honest, but I've tried Excel, and I know that Excel will struggle at some point. In terms of when the content of the report is large, all right, Excel struggle. So in the process of analyzing, you create pivot table, you do some lookups. It just kind of really help you, with your analysis. Okay. So a typical record, like I said, will contain, the scan host, the list of the host. Maybe the vulnerable port. It would give you the description of the services that are also vulnerable as well. It would give you recommendations in terms of how to fix those vulnerabilities. So like I said, if there's a missing patch, the scanner will tell you that the patch that is missing is this. It would give you the ID for the missing patch. Like Microsoft will normally have what we call the KBs. I don't know if you have seen some of this before. It would have that KB, and you could literally just go into Microsoft domain and further look at that patch and understand what it is. But it's important that I let you know that in an ideal situation, you shouldn't be the one fixing the problem that you have identified. That should be left to the IT team. Generally, your work should start and stop from the time that you carry out the scan. You identify the vulnerabilities. You put together a very good report. Then you hand over that report to the IT team, and I will show that pretty much later in what we call the vulnerability management life cycle. So this is, this flow just kind of represent what you would do. All right, I thought I would capture it, with this illustration here. So you usually start here, you run a scan, you generate your report. So this is really good as well, because if someone asks you to explain your what you do at work and what you would do from start to the time that you would hand over the report to the IT team, this is exactly what the flow looks like. All right. If you understand a bit of what's this called, Alex? What's this tool called now? The one that we use. It just went over my head. Lucidchart. All right, Lucidchart, or any other tooling that is there. You can create a nice workflow like this. All right. So that's you start from here, you run your scan. What follows is you generate your report. Like Qualys, for example, if you rightly set it up or configure it, you could run the scan and you could just go to bed. All right. So what Qualys, once the scan is finished, it will send you an email. You get the email. From the email, you can click on a URL. The email will normally contain a URL that will link you back to where the report is. You can download the report. So Qualys is a cloud-based solution. So all of your reports is not local on the scanner. It's all of them are in the cloud environment. So when you click on the link, you can actually download the report, for further analysis. So once you download the report, like I said, it will come in different format. The most friendly format, is the CVS. All right, CSV writer, is the CSV, which is pretty much like a different version of Excel. So you do that. You could do data extraction into pivot table, the Excel. All right, and this is where you do the analysis. All right, you slice, dice, do all of the crazy things that you want to do to it, and you could have a report. All right, after you've done the analysis. But what usually follows is you prepare and distribute it. Somebody was asking me, I think it was Jacob yesterday that was asking me, so how do you distribute it? Who does it go to? All right. I said mainly we'll go to the IT team, but if you are unsure, where to send it to, always check with your line manager. All right. Because, vulnerability management report, are supposed to be sensitive. So it can't be sent to everywhere or everybody in the business. Even if someone has asked you for the report, if you're unsure, always check with the line manager. All right. So you prepare and you distribute, assuming that you send this to the IT team, who's going to be involved in the remediation work. Then I'll say something in the vulnerability management lifecycle. Please remind me. So because when you shared your report with the IT team, it doesn't just end there. All right. You should, in a typical vulnerability management lifecycle, you should have a follow-up, meeting with them. Once you have the report to share with them, there should be a follow-up meeting. And that follow-up meeting is where you would walk them through the report, the findings. Of course, the findings will pretty much on, how you want to prioritize, the remediation. Again, it could be on severity, it could be on age, it could be the criticality of the asset, or a few other things that you're considering, for prioritizing your remediation. Obviously, they will do that. Of course, there will be back and forth meetings with them. Then you archive the report. All right, it doesn't just end. If you work in financial services where they are heavily regulated and also audit are carried out on a regular basis, you don't throw away your report after that. You're done with it. All right, you archive it, you keep it. And the reason why you archive report is just very simple. It might just be for audit purpose. It might be for compliance purposes as well. And it might also be for when something bad happened. So I think maybe it was on the first day, I don't know the question that someone asked, in case you get hacked, for example, something bad happened, you were hacked, and maybe the regulator have to come and investigate, all right, to actually prove that you have a robust vulnerability management, in your organization that you follow. This can be a proof for you. All right. So when the regulator, they won't be asking you, do you carry a vulnerability? They will just take over your system and start to ask questions. You have to evidence, that you have a proper vulnerability management in your organization. And the proof could be in the report that you have archived, over a period of time, and when that is there, and yet you still suffer an attack, they say no crazy person would actually sanction you or slam you a fine or heavy fine, because somebody hacked you. So if it wasn't a case of gross negligence, then you cannot, even if they have to sanction you, it would be minimal. Hence the archiving of the report sometimes. So guys, I'm telling you all of these things because you can see that I'm not just walking you through this thing. I'm telling you the reason behind it. The why is very important. So you don't say, oh, I archived the report. They will ask you in an interview why. So you must know the why. I distribute the report to who? All right. So if you say IT, yes, why didn't you distribute it to other department? You tell them the reason that you didn't distribute it to your other department because this sort of report are supposed to be sensitive. All right. It shouldn't be everywhere. And if anybody is requesting for it, it must go through the right channel. All right. I hope that makes sense, guys. Let me know if that makes sense to you. All right. So a few things that we talked about here. I just described them here. All right, data extraction in this phase of the process. Vulnerability data is extracted from the scanner platform and exported into the pivot table. That's so what some people would do is I've seen some places where the pivot table is already created. All right, and I'm not saying this is easy. All right, it's important that I say this to you. So I remember I did a piece of work somewhere, and there's this Indian guy that I was working with. He's very good with Excel. All right, where I'd struggled initially. So he said, hey, Sam, don't worry. So he created a pivot table, all right, a standard table for me, all right. I mean, I know what I wanted, but I struggled in terms of how to, make it work. And I said, oh yeah, I could do this. So he came because it's an Excel guru. He created it for me. We had different lookups. So the template is there. So every time that I take my raw data from Qualys, I just whack it, literally copy and paste it into a standard template that has all of my pivot tables and lookups, and because those formulas are built into my template, easy, I will just get everything, the desired outcome of the result that I want, because a table has already been built. Sorry, the formulas has already been added into my template. All right. So hence what I'm saying here, when you say you extracted it from the scanner platform and you export it into the pivot table, that's the explanation there, that you already have a table, a template created. When you take the raw data, you just put it into the template. And again, it will generate, with the formulas being already there, it will generate everything and give you a desired outcome. Prepare and distribution, data extracted is manipulated into appropriate format before being distributed with the management and those responsible for remediating vulnerabilities. So those responsible for remediating vulnerability is the IT team, but you could also have management, where you're sending a report to. Those ones you're not, as it were, you're not sending an Excel file to them. All right. You're sending them a summary of the overall security posture of your organization, based on the analysis that you have done using a pivot table. You're not sending them a summarized version. You will not send a CISO now, all of your Excel, they'll just throw it back at you. Archive report, I think I've already talked about that. So report can be technical and report can also be non-technical. So the Excel, the pivot table and all of that, those are all technical report because you are dealing with the IT team, all right? But non-technical reports usually go to, the business, all right? And this is where you would have very nice, fanciful, pivot tables. No, not pivot table, sorry. You have very fanciful, pie chart or bar chart, all right? Where you now quantify your risk into percentages, all right? That's what a typical business report will look like, okay? Again, I'm not going to be able to demonstrate anything to you here, in the real training, I would be able to show you something that you can take away. In fact, even coach you on how you can take data and present it in a nice format. It really helps. It goes a long way, to be honest, in your career, because a lot of people can do scanning. Scanning is easy. Let me tell you, bro. Oh, sis, it is very, very easy. You can, if you click, you will scan. All right. But what actually distinguishes you or makes you a very, very good vulnerability management specialist is ability to now interpret report and put it in a format that, CISO. See, when the CISO or CIO goes into a meeting, they just want to be able to talk about the overall security posture of the organization and what it will require, maybe to help, reduce the risk as much as possible. Probably, maybe you need more resource or you need to invest, in some, toolings. All right. So they don't need all of the Excel, hence, the non-technical or the business report. Some vulnerability scanner like Qualys and Nessus as well, I believe, they have different templates. So they have some template that you can select that template. So if you have like a 1,000 record now, and you wanted to create a business report from that 1,000 record, that raw data, there's a template that you can go and choose, all right, in Qualys that can help you to create a business report or a non-technical report. But even at that, it's not, because I've used all of this template before, it's not perfect. It's not perfect like the one that you have customized, for your business, or you have customized for your CIO, because what they're asking for sometimes, a default template or a template that is created by the vendor may not necessarily work for them. So whilst, there's some reporting template that is there in some of this, tooling, they're not usually perfect. It will still require you to be able to analyze your own data and report it in the way, the management want it. I hope that helps. Does that help? Does that make sense, guys? Okay. Let's move on quickly. I will skip some of this. So if you're writing, if you're consulting, say if you work for Accenture and you're doing vulnerability scan maybe for BNP Paribas, all right? Obviously, BNP Paribas would require that maybe on a regular basis, you're writing a report for them. If that is the case where you're consulting, so you will normally have a report like you would have the executive summary, assessment overview, result and mitigation recommendation. All right, so this is where you're doing some sort of consultation, for another business. All right, but if vulnerability management, you're being hired by, say, for example, BNP Paribas, and vulnerability management is what you do. You will not do this kind of, high-level reporting or this sophisticated reporting on a daily basis. All right, no, you're dealing with raw data and you're reporting immediately back, to the IT team that will be responsible for the fixes. All right, and even if you have to maybe report to the management, maybe on a monthly, on a weekly basis, you will not go through writing executive summary, assessment overview, mitigation. Again, it would be all about telling the business, about the security posture of your organization, all right, rather than writing a thorough report like this. But if you were consulting, if you've been hired as a consultant, to do this job for a client, then, you would write a thorough report. Like it will come in this format, like I just put here, executive summary, assessment overview, result and mitigation, and all of that. Does that help? I don't know. I hope I'm not confusing you. All right. So, if you're doing vulnerability management as a BAU, business as usual, you don't go through all this rigor of, executive summary, no, you don't do all of that. You just go straight to the point and fix the issue. All right. And report out, maybe on a monthly basis, rather than, being too formal. All right. So I'll skip all of this one. All right, so what do you look for in a report? A typical report, again, if you're consulting, of course, maybe scope, scanning error, plugin, signature version, date and time. You check all of that. Follow up on vulnerabilities findings. If you're doing this as a BAU, then obviously you would have categorized your, severity into different findings. You will send the technical report to the IT team. You would have a follow-up meeting with them on a regular basis. Where I've done this before, in some places it's a weekly catch-up. In some other places, it depends on your risk appetite. It could be, every bi-weekly, to do the catch-up. So after that, you've generated a report, you put it out to the IT team, then you have a follow-up meeting with them. Like I said, the frequency of the meeting can be weekly, others in some places, it can be every 2 weeks. When they do it every 2 weeks, they just follow the Microsoft Patch Tuesday. Some people feel that every 2 weeks, when you get that Patch Tuesday, then they can sit down with you and discuss, the vulnerability that you have found and what is possible, from remediating those vulnerabilities. They'll tell you what is possible and what is not possible. Then you will deal with it. And in dealing with it, I will talk to you about it pretty much later. All right. Types of security vulnerabilities. There are a few of them. This one I've just listed. Like I said, if you're looking for any vulnerability at all around mobile and web application, please refer to OWASP. OWASP is the Web Open Application Security Project. So all of the SQL injection, cross-site scripting, click-jacking and cross-frame scripting, broken authentication, you will find that they are quite common with web application. Missing security patch, unupdated software, that is quite common with network vulnerability or infrastructure vulnerability. Missing configuration sometimes, they are also quite common with infrastructure vulnerability as well. Insecure services or protocol, weak credentials, their system vulnerabilities. All right, so there are many, these are just example of some of them. We have talked about this earlier on, but I thought let's bring it back. We said that, how do you prioritize vulnerability? You can prioritize vulnerability based on, the severity of the vulnerability, and that severity, how do you know? You know the severity by the CVSS scoring of it. You also know, the vulnerability age, the exploitability of that vulnerability. So like we said that, some system can be vulnerable, but in actual sense, you may not be able to exploit them. The data or the asset or data criticality, sometimes it's not even about, the vulnerability itself. It's all about how important that asset is to that organization. Data sensitivity as well. It could be as a result of impact that, if the risk materialize, the impact that, that it would have on that organization. And impact could be the reputational damage, impact, could be what will come on the back of if you have a vulnerability on your system and it's being exploited. Impact could be, litigations and all of that. So on the back of that, you may want to on the basis of what I've listed here, you may want to prioritize your remediation. But there's also something that we call with the contextual, prioritization. It's beyond the scope of this course. So it's a conversation that is going on now in the vulnerability management community, all right, security community, basically saying, all right, all of this is good, but we need to put context, to everything that I've listed above. That, all right, yeah, if NIST can score a vulnerability to be 10, but 10 for NIST might be 5 for me. You know what I mean? NIST can actually score a 10 and say, okay, this vulnerability is 10. But in an actual sense, in my organization, if I look at this vulnerability, it can be 5 for me. Though NIST is saying it's critical, but it can be medium, it can even be low for me. So this is where this contextual prioritization, comes in, where you are now taking, you had some other data, all right, some other information, to the information that the scanner is giving you. Then on the back of that, you're looking at it and you're either, increasing the risk, you're either increasing the risk to the vulnerability that's been defined, or you're reducing it, all right? So there's something I'm going to show you later on that we call threat intelligence. Do anybody know what threat intelligence is? Threat intelligence? Anybody? Are people sleeping? Threat intelligence. No, Patrick. All right. Yes, Abdul. Any other person? Heard about it? Sorry. No, a lot of people do not know. No clue. All right. So you see, guys, it's not different from, you know, let me just put it across this way. All right. So you remember when we had ISIS, all right? ISIS was, you know, this group terrorized the world, you know, it was crazy, you know, all sort of attack everywhere in the world. Please, if you're an ISIS advocate, please, I'm sorry. I do apologize in advance. All right, I do not mean any harm, so that you don't go and attack me. All right, I'm just using that as an example. All right, so the group terrorized the world, you know, and they have their, you know, their ideology why, you know, things have been done, you know, the way they wanted to do it. All right, but listen, the leader, after some time, we just realized that one day we wake up and we heard that Bin Laden has been killed. All right, it took time. On the basis of information gathering, which we call intelligence, all right, to actually locate where he lived. And the moment they gathered that information and they were able to ascertain that he lived in that place, boom, you know, the SEAL went into action and they killed him. All right, so they gathered information. So we all know, just have, in fact, at some point they said Bin Laden was living in the mountains, you know, all sort of things that was going on. All right, but there were people working in the background, human being, all right, using computer, obviously, and all sort of, you know, toolings, you know, to gather information about this man up until the time they were able to locate him, you know, to where he lives, and, you know, they attack and they killed him. All right, the same is also true, all right, in cybersecurity. That is where threat intelligence comes. So most of the things that we hear in cybersecurity, let me tell you, they are military terms, all right? So threat intelligence as it is in the military, all right, this is where we bring that into cybersecurity as well. So what we're saying is, all right, you can gather information, and we call it enrichment. All right, the information that you gathered can enrich the information you gathered outside of your organization or outside of the information that the scanner is giving to you, can also enrich the information that the scanner has already provided, that would now help you to make an informed decision, all right, on how to prioritize, you know, your remediation. All right, so there's something we call the deep and the dark web, all right? So you can, the name is even scary, deep and the dark web, all right? So the deep and the dark web is beyond the internet, all right? You can liken it to outside of the internet, all right? And people are there. All right, people access such environment, all right, using special toolings, all right, to assess that such environment. So there are places that you can't just go to, your computer cannot get there. If you want to get there, all right, there are special toolings that you would have, all right. This is not a class to teach deep and dark web, but I'm just trying to explain it to you, all right. So because in that place, there are certain information that is not, you know, available on the internet, hence it is called deep and dark, all right. They are not available, you know, they are sensitive information, all right? So when you want to contextualize contextualize prioritization, all right, some organization will pay for such service, which is the threat intel, all right, where certain organization, this is what they specialize in, all right, they will collect threat intel from the deep and the dark web and the other places. And those information which are valuable, you know, they would ingest that information into their vulnerability management, all right, that would help them to bring about this context prioritization, all right, context prioritization, okay? So it might be information about a particular organization, all right? So cyber criminals, like, you know, they don't just put information on the web where everybody can access it. They go into those deep and dark places as well, you know, where they are dilly-dallying, also, not dilly-dallying, where they are also chatting about the possibility of attacking an organization. All right, so if there's a possibility of attacking an organization, that's an intelligent, all right? And you could use that intelligence and use it to enrich the information that you're collecting, all right, about your vulnerabilities on the surface. In fact, the more we've been talking about exploit code. All right. So the deep and the dark web, sometimes there might be an exploit code for a particular vulnerability that is found in your organization. Though CVSS, might rank that vulnerability as low. But if there's an exploit code in the deep web or the dark web that your intelligence have collected, then on the basis of that, you could prioritize the remediation of that vulnerability because you have had another data that is enriching the information that you are collecting on the surface. Does this make sense? I don't know, because I'm saying certain very complex stuff. Okay, Abdul says yes. Twin says yes. Somehow. Obatoday says yes. More digging needed. All right, let's see if we can answer some questions towards later. But let's just move on so that we don't waste a lot of time here. All right, so this is different intelligence. Of course, this is not a threat hunting class. If I was teaching you threat hunting, then it would be something different entirely that I'm going to be talking about. Or perhaps I'll be able to go further, and give more context and provide more information, but it is not threat hunting, all right? It's only a few organizations that they collect, that they enrich their data, or they do what is contextual. Give me a sec. It's only in few organizations that they do this thing, this contextual prioritization. Very, very few. All right. Well, let's move on anyway. So vulnerability management and threat intelligence. The point I'm trying to make there is you can combine both. All right. You can be collecting vulnerability data, then threat intel data on the other hand. You can combine both of them, use your threat intel data to enrich the information that you're collecting from your vulnerability scanning. And that would also help you, to make an informed decision on what vulnerability, to prioritize. All right. I'll just leave it at there, so I don't want to complicate it. It's really a little bit beyond the scope of what I'm teaching you, but hopefully, when you come for the big stuff, I'll teach you more. Our threat intelligence of vulnerability prioritization, understanding the relevance and the severity of vulnerability, information about exploit and exploit kit. These are the sort of things that you will get in the wild, all right? Exploit and exploit kit. Mitigation techniques, clarity to access to, access business risk. Yeah. Bottom line, cyber threat intelligence can help your vulnerability management analyst to better understand how and by whom vulnerabilities are likely to be used, reduce risk to the business by better prioritizing the vulnerability based on the real threats to the industries and the enterprise, lack of offsetting the security defense and control, and the availability for exploit. Understand and apply optimal mitigation techniques. Communicate in business terms with auditor, risk manager, and also IT group about risk created by vulnerability. So there's so many toolings that is there, and I've used some, to be honest. Maybe when you come for the briefing, I can share some stuff with you where you can actually, combine threat intel with your vulnerability management tools, and you can get some very nice information from it. All right, these are source of vulnerability intelligence. You can see FireEye. We have some that are open source. We have some that are commercial. Yeah, a lot of threat intelligence, but I would recommend that even if you decide, you want to go for any threat intelligence, make sure that they are those that they have knowledge of the industry you work in, the ones that have knowledge of the industry that you work in, so you can select the right vendor. All right. Vulnerability management lifecycle. So we're going to look at vulnerability management lifecycle. Vulnerability management lifecycle is a business process that never ends as long as an organization actually exists. So if you have a vulnerability management lifecycle in your organization, it shouldn't only focus on scanning assets for vulnerability. Rather, it should take a lifecycle approach. Lifecycle approach just simply means that the vulnerability exercise has to be constantly going through these different phases that I'm going to show you. And the first phase being this one, what we call policy establishment. All right. So, so this is what it looks like. You have number one, policy. You establish a policy, a process, standard, and guideline. Number two is the inventory. All right. Discover all assets across the network. Number three is where you actually do, number three, see this one, this red flag, is where you actually do the scanning. Number four is where you prioritize assets based on assign business value to the asset after the inventory. Vulnerability, determine vulnerability on the asset. So ignore this one. You're actually doing the scanning here because once you do the scanning, then you're able to, determine the vulnerability on the asset. Threats, view potential threat. Viewing potential threats does not necessarily come from the vulnerability scanner because scanning does not have that capability, to tell you your threat actors. Though Qualys and some other tooling now, they have something around what they call threat protect. It's like another model within the suite of their product. But not all vulnerability scanner has this ability to tell you what your threat and your threat actor is. All right. But in your vulnerability management cycle, you can have it. You determine the risk because remember I said that your vulnerabilities vendor sometimes they do risk scoring. That simply means that once you get the report, Nessus will do risk scoring for you, so you can determine the risk. Then obviously, before you do the remediation, you want to make sure that you do reporting, and that will now lead to remediation. You measure the impact of your decision and also compliance as well. So let's go through one by one what this actually means. Before we get there, vulnerability management should have a strategy. In some organizations, you should have a strategy, but you are not the one that would build the strategy. All right, there's something we call vulnerability management strategy. It kind of comes together with, the vulnerability management policy, processes, and procedure as well. So strategy will be high level, high level plan in terms of, how you carry out your vulnerability management or scanning or assessment on a regular basis. So a successful, approach, will focus on 3 areas or 4 areas: prioritize assets, determine risk level, remediate vulnerability, and also measure the effectiveness of your vulnerability management. So let's go to each of the cycle. So number one is policy. So policy is a type of non-technical controls. All right, non-technical controls. Most times they drive our technical control. All right. So you need to have a vulnerability management policy, that explains why you're carrying out your vulnerability scan and assessment, the frequency at which you carry it out, and what is the driver. All right. So you need a policy. The policy will drive what you actually do. All right. The scanning itself, the policy will drive it. All right. So followed by your policy should be the process and also the procedure as well. Sometimes some people will have some guideline. So this is very, very important so that you don't do things haphazardly. You don't just carry out a scan, but you are carrying out a scan, that is driven by well-documented processes. All right. So what you need first is a documented policy, that comes with a process as well. All right. Inventory. Inventory is very important because if you do not have asset or you do not have a knowledge of your asset, then what are you going to scan? It's going to be very, very difficult. And this is so important to the success of your vulnerability management. You need to know all of your assets. Whilst it is not your responsibility, But most times, as a vulnerability management specialist, you usually find yourself in between the management and the IT team or any other team that is responsible for managing the asset records. All right. If you're unsure where you are working, just go and ask the management or ask the IT team or the network team. All right. Do you have an inventory asset here? What are IP addresses? What is the range of our IP addresses? You ask that questions, because if you do not have a good response, then perhaps you might not be able to, accurately scan your environment. All right. Prioritize. Assign business value to the asset. Remember, all right, you will not be responsible to assign business value to your asset, all right, because you're not in the management. People that usually do this, they are people that are senior in management, all right, that understand the value of the asset. They can tell whether this asset is critical or not, all right? So you should have an inventory, all right, of asset that also include, the value of the asset. When we say value of the asset, whether the asset is critical or it is non-critical, all right? What now follows so this is established process and standard and guidelines. I'm just giving again, what that means. Define roles and responsibility. The steps: prepare vulnerability scan, define remediation action, implement remediation action, and risk scan. All of this can be captured in your policy, all right, in your vulnerability management policy. All right. So you see what you have here is a typical workflow, all right, of end-to-end approach to vulnerability scan. Don't take this as it must always be like this. It was something that I created some time ago. You just need to understand what this flow is all about, all right? You can see here that you start scanning from the top to the bottom, all right? You can see start, you carry out a vulnerability scan. Once you carry out that vulnerability scan, is go to vulnerability review. Vulnerability review in the sense that, of course, once you have the scan, then the result, you want to review the result, all right? Then it follows identify vulnerable asset. Then the question you ask here, so this decision box is asking question, is asset critical? If the asset is not, it goes back. If the asset is yes, then you check the asset inventory. All right, you perform what we call a risk assessment. All right, if you perform the risk assessment, you ask the question again: is the asset at risk? If it's a yes, all right, you start to fit remediation. If it's a no, you go back in that loop. All right, I'm not saying that you would understand this. All right, you even took me years as well, to be able to come up or kind of put my own flow together. All right, just like this. All right, but you can get there. So this just depicts an end-to-end approach, to you carrying out a vulnerability scan, what you would do, all right, and who is going to be involved. You can see here, even up until whether you're asking whether the asset is at risk. So you can imagine that you're having a conversation maybe with your IT team to tell whether the asset is risky or not. If it's a yes, then remediation would commence immediately. Implement change, risk scan, report, and hand. If it's a no, drive actionable plan to mitigate, vulnerability. Risk scan, monitor the vulnerability, report, document risk, and blah, 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 blah. All right, so this is a typical, if you're a business analyst, sometimes you might be required to create, an end-to-end workflow for a vulnerability management process. If you're a business analyst, in some places, it might just be the vulnerability management specialist, that would create this workflow. So this is an example of a workflow that I created, a vulnerability management workflow. All right, so this is one. This is another version of it. All right, this version is just only, trying to talk about how you will prioritize, your vulnerability. All right, so we started from, again, it starts here. You discover an asset. So the discovery of the asset, the scanner will do it. remember, like I said earlier on, that one thing that Qualys will do when you start scanning is to discover the asset. All right. And once the asset is discovered, the next thing would be vulnerability scan. All right. You carry out the vulnerability scan. So if you look at here, there's a loop between vulnerability scan and asset discovery. It says here, vulnerability notification or alert, all right, external source. Sometimes, I think what I'm trying to say here is, sometimes when you carry out vulnerability scan, it could be as a result of information that you have gathered from an external source, all right, about a particular vulnerability. So the point I'm trying to make there is, you could gather an information about like the zero-day attack, all right, zero-day attack, zero-day vulnerability, zero-day vulnerability or zero-day attack, in other words, you could gather an information that, all right, we have log.js, log4j.s, in the wild. Then it's on that basis that you're carrying out a vulnerability scan. So what we're saying, that you discover an asset, then you're asking the question whether, is this a notification from the vendor, or is this something that you have just come from the wild? All right. Then if it's a yes, you're asking whether it is internal to your organization. Then follows by vulnerability identification and also analysis. So this is where you're carrying out, this is where you're actually doing your vulnerability assessment. You're identifying the vulnerability, you're also carrying out a further analysis. Then you see this decision box. Is the system at risk? If it's a no, it goes back. But if the system has risk, then you start to do your prioritization here. All right. So prioritization, you triage. And triaging, I'm still going to talk about that pretty much later. And when you're prioritizing, there's so many things that you can use for your prioritization. Number one is, asset criticality, whether there's a proof of concept, which is exploit code, whether there's a business impact, whether there's a VPR rating. So this VPR rating is common to Nessus, not all vendors. So Nessus would have that VPR rating. And whatever it is, you start the remediation work. So you can see my arrow here, remediation, you look for the patch or the workaround, you apply, you find and apply the countermeasures or the patch, you rescan, you report, then you end that cycle. All right. If it's a no, again, drive an actionable plan to mitigate the vulnerabilities, rescan, report, document the risk, and end. Then this one optional, say for example, if you cannot fix the problem, you can mitigate it, you can remediate it, then the third option is, trigger an exception, all right, exception request. This is where you cannot fix the problem, you can't remediate it. Maybe you just want to accept the risk. That will usually follow, what you will trigger there is an exception process. So you look at here, exception require, if there's an exception process, if there's an exception in place, you would ask for exception. If it is approved, you will document the risk. If it is not, it goes back in there. If it's a no, remediation plan, change request, raise. All right. But if it's a yes, if there's an exception, then you document the risk. Exception is where you cannot, fix a problem. All right. You can't fix it because if you attempt to remediate it or mitigate it, you might even broke something further. All right. So an exception could be triggered. So exception is a different process entirely. All right. Exception could be triggered. This is where you take this problem to the management, telling them that, listen, I can't fix this problem. All right. What do you want to do? All right. Then they would ask further questions. Once the exception is approved, then you can now take that risk, that vulnerability as a risk. You can document it in the risk register and you can monitor it over a period of time. I know I've lost a lot of people. All right, well, let's just go on. When you listen to the video, pause, it will make a whole lot of sense to you. All right, inventory. Okay, this is the second stage. The inventory is very important. I think I've already talked about it. You need to know all of your assets. You need to know if you have a server now, you need to know the system type, the version of the software that is running on the system, whether the system is physical or logical. the logical addressing, network addressing, the IP addresses, the owner of the asset, where possible, the data sensitivity on the asset as well. So again, whilst you cannot determine all of these things yourself, you need to get the IT team involved. If they already have an inventory, then maybe nice, you can always refer to that inventory if you have any further information. If you require any further information. So a typical inventory could be the CMDB, all right? Some of you must have heard about CMDB. So CMDB is the configuration management database. Some organization would have it. Typically, it will look like this, all right? Where they will keep all of the assets, okay? Vulnerability scanning, no, I won't go there. You could do authenticated and unauthenticated scan, but before you do the scanning, you're also, the prioritization of the asset, which I've talked about. You will not be responsible for the prioritization. If you have the inventory, all right, that record or the database could also have the business, the scoring of the asset as well. It would clearly depict that how the asset are scored, all right? Don't forget, the reason why you need that information is such that if you need to prioritize your remediation, if you have a knowledge of the business value of an asset, then maybe that would help you. But the only place that you can find that information, it would be in the inventory, all right? In the inventory. And again, prioritization of that asset is usually based on their criticality. Correlate threats. But before we get to the correlate threat here, you would have done the vulnerability. That is number 4. Number 4 is where you actually done the scanning. The scanning would have been done now to determine the vulnerability on the asset. All right. Yeah, and you know what the scanning is anyway. You scan, then you identify the vulnerability. When we say you're correlating the asset, the threat, not all threat and vulnerability data have equal priority. Primary goal is to rapidly protect your most critical asset. All right. Identify threat, worms, exploit, wide-scale attack, new vulnerabilities. Not all vulnerability tools will do this. All right. But when you're analyzing your vulnerability, you might, also consider the threat that is in the wild that could exploit that vulnerability. All right. Like I said, some tools does a sadness, no, not sadness, Nessus does it. All right. Nessus actually does very, very good with ability to correlate threat for you. Qualys also as well. As I've seen some modules, where they have some modules which helps, with, they call it threat protect. It just gives you just some correlations and gives you an idea, of what could possibly, maybe a worm, a rootkit, or something that could possibly exploit your vulnerability, if any. Determine the risk level. We've already talked about this. Some vulnerability tooling will do the risk scoring for you, and it can just make a whole lot of sense. And the risk scoring is based on certain algorithm. There are certain things that they put into perspective. It's very similar to how the CVSS is also scored as well. All right, they can think about the scoring of the vulnerability, the exploitability, consider the threat, consider the environment. I don't understand the algorithm that is used or the criteria that is used. I'm just only guessing here how these tools would also score the vulnerability that is found. The point is varies from organization, it varies from vendor to vendor. You might ask the question if you want to choose a particular vendor and they have that feature. Qualys have it, Nessus also have it as well. They have the feature for the risk scoring. You can ask that question, how the risk scoring, actually work. And I'm sure that, the vendors would explain that to you. But the takeaway for you here is just to know that, in the reporting, some tools also do risk scoring as well. Remediation. Yeah, so obviously now you have the vulnerability, you have, the risk, has been scored, then that will now lead you to remediation. But remediation, if you don't go by the risk scoring and the severity, don't forget that there's so many other things that that can help you prioritize or determine, what to remediate first. And I think we've already, talked about it. But whatever it is, you should proactively, fix vulnerabilities, based on their severity. But there could be other things or other criteria that you can use, to base your remediation. All right. So remediation resolution, you do all of that. Remediation, you do the 80-50 rule. 80% of your risk can be eliminated by addressing 20% of your issue. This is also true in some circumstances as well. I've seen a situation where you might have large record of vulnerability, massive record of vulnerability, and you might just be wondering, how to fix it. So some people will use this 80-20, percent rule. All right. So they may look at certain assets. Some assets, just on a single asset, sometimes an asset might have up to 700 vulnerabilities. All right, just on one single asset. So if you look at that across your estate, and you find some assets that have more of such vulnerability, maybe one asset, maybe out of 1,000 assets, maybe 700, individual assets may have, maybe like each of them have about 600 vulnerabilities. So the 80-20 could be, let's fix, target all of these particular, maybe level 3 vulnerabilities or medium vulnerabilities, and if we're able to get rid of all of that, maybe we can reduce our vulnerability, maybe from this 70%, to 20%, or from 100%, to 10%. So that's what about, 80-20 rule is you're just looking at the most vulnerable asset, and you're targeting them, to remediate those vulnerabilities as much as possible. All right. Remediation, as you know, can come in form of, applying patch. It could also come in form of, misconfiguration that you're correcting, and a few other things as well. Measures, this is where you actually measure the effectiveness of your vulnerability. But there's so many ways that you measure the effectiveness of your vulnerability management in your organization. And that would take us to, let me show you what it would take us to. All right. Yeah, it would take us to what I call vulnerability management maturity model. All right, maturity model. I'm going to show you that in a few minutes. You can measure the effectiveness of your vulnerability management by using one of, SANS maturity model, and I'm going to show you in a few minutes. But before we get there, there's something we call vulnerability management workflow. All right. This workflow is something that you can use, to be honest, when you're working, when I say working, you get your own job. All right. So these are workflow vulnerability scanning process. Typically, when you're carrying out vulnerability scanning, in a vulnerability management environment, you will not be alone. You will have different people that are playing different roles, per time. So you might occupy the role of a SOC analyst, but among other things that you do is you carry out vulnerability scan. All right. But typically you would also have asset owner. These are the people that are responsible, or they own the asset that you're scanning. Then you may have the customer. So the customer are the people that make requests at you, to scan their environment. Okay. So a request can come from the customer, all right, that end up on your table to scan a particular asset. All right. If that is the case, so the whole process will start from here, where you start scanning. And when you scan an asset, the report, you can send the report to the customer who has asked you to, who has made a request for a scan. All right. They will check the report if it's good. If they find any issues, all right, they'll flag that back to you. If there are not any issues, they would accept the report. All right. So I think what I'm trying to show you here is, there are different players when you're carrying out vulnerability management. When you're carrying out a vulnerability scan, it could be yourself involved. You can be talking to asset owner, or you could also be talking directly to the customer. So hence this flow that you can see here, all right? Communicate issue, all right, if there's any, back to the SOC analyst, or interchangeably the vulnerability management analyst. And they will take on that issue and they would make, do a risk scan. All right, we also have this workflow as well. This is another one. If you're packaging an agent into the cloud, this is specifically for Qualys. So I said to you that there are so many ways that Qualys actually scan. All right, Qualys uses agent, we call it cloud agent base, so this is where you deploy a piece of widget onto onto the server, all right, and that widget is what actually does the scanning. So if that is the case, you would also have a workflow like this, where you're packaging an agent, you put it onto, so you can see here the customer request asset onboarding, and when that request is come, it might go directly to the project manager. They will validate the request. They will ask the question, is this info correct? If it is, the agent is packaged by the SOC analyst, and that it goes to maybe another team that will deploy the agent, the IT team or any other team that he uses. And once that is done, is issue detected? If yes, they will communicate that back into them. If no, then the agent is packaged on the server and the scanning is done, pretty much later. So this is agent packing. Then we also have the vulnerability management process. So everything I've also been talking to you about earlier on is captured in here. But what I wanted you to focus your attention here is this decision box, where I'd call accept risk or not. So if there's a risk at all and you want to make a decision whether or not to accept it, this decision box will help you. If you're going to accept that risk, then it might trigger what we call the exception process that I showed you, that I was talking to you about earlier on. And what would happen is if it triggers that and there's an exception process that was actually accepted, then you document the risk in a risk register and the whole process would end here. If the risk is not accepted, then you have to define what we call the corrective actions. All right, and that process will end here as well. So quite a number of flow. These are just a few examples just to depict what you would do per time when you're when you're at work and you're doing some of this work on a regular basis. This is another one for risk scan. All right, so you can imagine after the remediation has been applied, you've fixed the problem. A SOC analyst or a vulnerability management analyst would actually do a risk scan. All right, they will carry a risk scan against the target host. And once that risk scan is done, they will feed back that information, maybe to the IT team or to the customer to tell them that, oh yeah, I've done the risk scan and all the implementations, has been, done correctly. All right. They could also feed that information back to, the asset owner as well. All right. So this is an example of another flow that depicts a risk scan. This is an exception process that I mentioned earlier on. So exception process is all about decision making as well. So you have identified vulnerability. You're asking the question here, is it possible to remediate? If it's possible to remediate, then you apply a fix and you validate. Validating could just mean that you're carrying out a risk scan. If it is not possible, you ask another question. You can see here, you canceled it out. You are asking the question, is it possible to mitigate? If it's a yes, then you apply the mitigation control. All right, then you revisit, on expiration. If both are not possible, remediate, mitigate, then obviously you have to accept the risk. So if risk is accepted, then you come here, approval of exception, you revisit. But like I said here, the extension is if the risk is accepted, then what would happen is you would take that risk and you would document it in the risk register. All right, this is a maturity model. This is from SAN 20. This is really way beyond the scope of our training, okay? I'll just leave this, I'll let this pass for now, but if anybody's interested to learn more about the maturity model, I can discuss with you, or when you sign up for the real training, then we can talk about it. But one thing that's very important here is you can see 6 levels across. All right. There's a saying that whatever that you cannot measure, you can actually prove whether that thing is working or not. All right. So hence this model. This model helps you to measure the effectiveness of your vulnerability management program. So if you have a vulnerability management program, then this would help you to determine whether it is effective or not. All right. So hence you can see here level 0 to level 5. All right. So what this one is essentially saying is, if you're not sure whether your maturity model, whether your vulnerability program is matured or not, you can ask certain questions. So if, for example, at your work, you don't have a vulnerability scanner, you don't scan at all, all right? And let's say you don't scan at all, then your level of maturity in your organization, you are level 0, all right? Let's say in that organization, you just only patch your environment when you feel like doing it. So it is haphazard, all right? You don't do it on a regular basis, all right? Again, you are at level 0. So let's say no process exists. You don't even have a vulnerability management policy. You don't have a standard. Nothing is documented. You are at level 0. So you can ask questions and then ascertain the maturity level of your vulnerability program in your organization. By the response that you get, you map it, to each of the criteria in each of this level. All right. So let me take you to level 2, level 1. All right. So level 1 says, level 0 says non-existent. Level 1 says scanning. So assuming that you're carrying out vulnerability assessment solution, you have a vulnerability assessment solution in place, you have a scanner, all right, and you're scanning, maybe once in a while, all right? So if you're doing that, you are level 1. The scanning once in a while means that it is on ad hoc basis. You don't do it on a schedule. It's not scheduled. You only maybe you scan today, and the next time you're scanning is in 1 month's time or 2 months' time. All right, you are at level 1 because it's on ad hoc. All right, or it's when somebody has made a request for you to scan. All right, you're on level 1. All right, let's say that when you have done the scan, you also do what we call the rudimentary patching. You don't even patch quite often. You don't have a process. You just only patch when you need to patch. Then again, you are at level 1. So your process is basic. You have a policy that you don't follow. You have a process that you don't even implement. All right, then you are at level 1. You have basic metrics, as in you don't even measure. You don't report to anybody. All right, you are still at level 1. So you don't get it. But the questions that you ask, based on the evidence that you collect, will determine the level that you are. You see, this is the most desirable level that every organization should be in. This is where you do continuous patching. This is where all threat vector scanned and prioritized. This is where you're combining threat information and your risk aligned with the business goals. All right. This is where you have a unified business and IT process. This is where you have measurement integrated to enterprise risk management. All right. This is the most desired level 4 and level 3. Level 4 and level 5. But questions that you ask, all right, would determine, or you help you to determine what level you are per time. So this is a very high level, vulnerability maturity model. All right. This is from SANS 20. But again, if you want to learn more, I have more information that I can pass on here. All right. We're getting towards the end now. Patch management. I'm only just going to spend like 5 minutes or 10 minutes here, and we're done. All right, patch management. All right, what is patch management? All right, is the process of repairing system vulnerability which are discovered after the infrastructure component has been released into the market. This is why it is necessary to devise a patch management process to ensure the proper preventative measures are taken against the potential threat. So I said here, the reason why I'm teaching you this, or just to show you a little bit about patch management is, it works well for you. Your principal, stakeholder, in vulnerability management program is the IT team. And if you do not understand how they carry out their patching, the patch management life cycle, the tooling that they use, all right, you might struggle a little bit. So, the knowledge of this would also help you. I'm not saying this is a patch management, all nice and comprehensive patch management training course. You only just give you an idea, what it is and where you fit in the entire patch management life cycle. All right, so patch management, you could also liken it to a strategy for managing patches and upgrade, for software application and technology. So software patches are often, necessary in order to fix problems with the software that are noticed after the initial release. So many of these patches have to do with security, and that's correct. So we have different types of patches. We have what we call the bug fix patch. We have security patches. We also have feature patches as well when new functionalities are added. And I think I explained that earlier on. So while, the feature patches are important or they're nice, I think you're more interested in the security patch and also, the bug fix patches as well. All right. So, and why that is important to you is so that when you pick up your vulnerability and your vulnerability comes back with, unpatched software, it's important for you. Of course, the vendor, Qualys will pick up or Nessus will pick up or any other solution will pick up is pretty much around bugs and also security patches, and trust that it won't pick up anything around feature, functionality patches, because those are not security related, but it's important for you to have an idea of what it is. All right. So these are all the types of patches, hot fixes, hot release, security patches, service pack, and all of those nice, source code patches and blah, 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 blah. All right. So hot fixes versus, patches. The term hot fix is often used, synonymously with patches and fixes, but usually only because it gives the impression of something happening quickly and proactively. Yeah, that's hot patches for you. So the relationship between patch management and vulnerability management. Patch management, like I said, is a process and it is used to update the software, operating system, and application on an asset in a logical manner. While vulnerability management is a process that discovers assets in the network, categorize the OS and application on the asset, and report on security vulnerabilities in the target system. All right, so let us now look at the relationship. All right, so what is the relationship, all right, between both of them? So this is where I'm rounding up now. So monitor vulnerabilities, all right, establish priorities, manage knowledge, test patches, implement patches, verify implementation, improve the process. All right, so monitor vulnerabilities, inventory scanning, vulnerability report, and also alert as well. So IT uses different toolings. They use what we call WSOS. They also use what we call SCCM, all right, in some IT. They use WSOS and SCCM. SCCM, they also use this tool called WSOS as well. These toolings are used, to deploy patches. Sorry, I wanted to send this to everybody. They use these tools. These tools are used to deploy patches, all right, across the network. But these tools also have some capabilities as well, all right? Apart from deploying the patch, you also get some reporting out of it. So vulnerability, like we said, scanners, Qualys, Nessus, and a few of them you can use it, to monitor, vulnerabilities. Number one, the inventory. You could use it to monitor the scanning and also the vulnerability report as well. All right. Establish priority. Obviously, the vulnerability scanner will do that for you. It can help you to establish, a priority, a risk-based approach, triaging vulnerability, accepting risk, unacceptable risk, and also controllable risk as well. So we know that based on the information that you will gather from your vulnerability scan, you can tell what to prioritize and what not to prioritize. All right. Manage knowledge. All right. So most toolings like Qualys and Nessus, they also have a massive knowledge database. Where you can get a lot of information about reported vulnerabilities, both now and also both now and the ones that are reported previously. All right. They are usually linked to extra resources where you can get more information about a known vulnerability. All right. But where that kind of in that cycle now is the test patch. This is where before remediation is applied or you mitigate a vulnerability that actually had to do with patching, the IT team, what they will first do is to take the patch, and test the patch. All right. They don't just deploy patch. Any patch that they collect from any of the vendor it doesn't just automatically goes into the product environment. It must first be tested properly, to ascertain that there is no bug and it is suitable. So once that test is done, that is when it is now deployed onto the product environment or maybe another testing environment. In some organization, they would have what we call the pre-prod. They would test this in a particular environment before they deploy it onto the target machine in the production environment. So what usually follow is they would implement the patch. The patch would help to reduce the risk. Most times, it doesn't necessarily transfer the risk, but the risk would be reduced, once, the patch is applied. They also do verification of the patch as well. What that simply means is the tooling that I mentioned earlier on, the SCCM and also the WSOS can also be used, to ascertain whether a patch has been properly applied or not. All right. Don't forget that in scanning, if you're doing a risk scan, your risk scan is to validate whether the vulnerabilities has actually been taken care of, through the patching. But also, IT team can do that as well by using, their tooling. So once patch are deployed, they could use this to tell whether or not the patch is applied properly or not. Of course, the last one, which is, you improve the process. You look at what is not working. You do further training. You automate the patch management solution, and a lot of lessons that I can also be learned from there. So what is the takeaway here? For you that you are aspiring to become a vulnerability management specialist, at all time, you must understand, the patch management dynamics as well, because IT team are your most, your close body, if I can put it that way. They're the ones that you're going to be talking to on a regular basis. So hence, you need to understand how things work, their tooling, the frequency of their patch, and how you can ensure that you work effectively with them. So on this note, I will say thank you. We have come to the end of this journey. It's been a wonderful 3 days training. I'm thankful that you are still here. We still have some people there. So thank you. I hope this has been worth your while. It's been very, very good for you. I know quite a number of people are tired, and I am tired as well. But we will stop here because we're done. All right. So we're done. All right. So I would stop recording. I would open the floor if there are any questions or any follow-up questions, I would answer them. And then I would also tell you what is next as well for those that are interested, and we will take it from there. So I will stop recording now.